Hey, good morning, Walter. Welcome back. You feeling better now?
Yeah, I am. Thank you.
Okay, great, great. Um, awesome. Okay. The rest of you should feel free to switch on your cameras and join the meeting. Um, yeah, I see that a lot of you are um, persevering really hard to nail the final quest and all. So that's really cool. It's really cool. All right. So we're going to wait for a few more people, I think. Nemo was coding. We need the code from last class because, I think we should be able to complete that roulette game. Maybe even today, right? I was thinking Thursday, and then we'll end the quarter on a bang, like, playing the game roulette in class. But I think we may be able to do it today, proper with different people allowing multiple classes. It's actually going to be a pretty cool project, I think. Well, I hope so. I hope so. We'll see how it goes. Okay. So yeah, Nemo's here. Should just pick up the code that but I don't know who's going to code today. Everybody is coded, as far as I can tell. Only it's me and Walter. So but no, I think there's a couple of people who still wanted to code, but they haven't had a chance. So we'll give them a chance to, appear on screen first, and then they can code. Until then, you guys should just feel free to talk. Switch on your cameras and talk to each other, and then we'll start in about five or 10 minutes, okay? And what I'll do, I'll just turn the laptop around for 5 minutes, okay? And then you guys can keep chatting. You can ask Walter any questions you have too, and obviously me too. So feel free to do that. Okay. Hey, Will, you coded the class before Nemo, right?
Yeah.
Yeah. Okay. Um, well, Alec maybe coded a long time ago. Maybe he can come back and code. So we'll see. I mean, if nobody
Just
else wants to
completed
code,
quest 9.
who's on? Yeah, I know you're on quest 9, Robert. I've been
No,
I've been
I,
watching your
I basically
submissions and
completed
all.
it.
Hmm?
I basically completed it.
Oh, you did. Wow. Okay, but I when I looked last night, you were halfway through it or something. When did you complete it?
Like 12.
All right. Okay, that's probably why. I was looking just before I went to bed. Took a look, and I think you were about halfway. Well, and a few other people too. All making very good progress. So that's fantastic. Hey, Robert, are you in my 2B next quarter?
No, I'm taking a different class.
A different 2B or a different class?
Different classes.
Okay. But you are planning to do 2B at some point?
Uh,
You are a
maybe.
computer science? Are you a computer science person? Computer science major?
Almost. I'm I'm well, I'm thinking of being one. Yeah.
Okay. Yeah, you should seriously think, consider being one. Uh, wow, it's so funny. Peter, who usually comes here to eat, peanuts and apples, he's just going crazy eating all the leaves on my, snow pea plant. So I don't know if there's any nutrition in there, or maybe there's maybe there's some minerals that. All right. Okay. Cool. That is so funny. Hey, but you should definitely consider 2B. I think you'll have a great time. Okay. I think you'll enjoy 2B, especially since you will get credit for all your 2A class. All your blue class, you get credit in 2B. So you should absolutely consider doing that. Um,
Yeah, I might do it in a different quarter.
yeah, a different quarter, but keep in mind that even 2A, I'm only going to teach for 7 more quarters. Okay, because my retirement, it's not been accepted yet, but I think there's a very good chance. It needs to go to the board meeting and all. So, and that's not until later, I'm told. So, but I'm very sure that max, I think 7 quarters for 2A, which means 2B will be offered fewer quarters than 2A generally. Okay, because it's like a funnel. Students kind of drop off as the course, the sequence get harder and harder. So more 2A sections, fewer 2B sections, and even fewer 2C sections.
He
So which means,
just left.
Andrew, you said
Oh,
something?
okay.
I do. He probably didn't close all the way. It's okay. He probably didn't close all the way, and the dog.
Sorry, didn't realize I was unmuted.
All right, okay. Okay, so I actually forgot what I was saying, but yeah, 2C, 2B and 2C. Maybe I'll offer, 3 or 4, 3 times 2B, and maybe 2 more times, 2 springs. Okay, 2C. So but try and make sure, because because all of you guys are so everybody who's in class, I see you're so excited and enjoying the subject and all. So I would really like to have the opportunity to teach you all the way through, right, until you finish 2C. And if you finish 2C, you're actually job ready, okay? Meaning that I don't care what other qualifications you have. If I'm a hiring manager out there, I would be happy to hire you if you finish 2C and maintain a good profile on Reddit. I would be very happy to, well, if I was still hiring and all. So I would be very happy to hire. And comparing my experience to people I've hired who've come from, reputed universities. And then my finding out what they knew and what they didn't know, I'm actually finding out a lot more right now. And I find that the key ingredient to the success of any employee we hire is not even really the prior knowledge they bring in, is really their interest in the subject and their eagerness to find out more things. And I think I see that in all of you guys, okay? And also you have the latent knowledge and talent that is starting to shine. So I think you'll be a fantastic people to continue all the way through, and seriously consider even making your own product later on down the line. I think you'll have great success with these things. Okay, all right. So So how about Connor and Darshana? All right, so you guys should all switch on your cameras, okay, at the earliest. And then what we'll do is, you know what, let's start coding earlier. Let's not wait until 8:10 and all. What time is it now? 8:09. It is already 8:09. Right, so we can start coding. Someone should pick up the code that Nemo wrote. Hey Nemo, did you share the link? Yeah, you did share the link on Reddit. Yes. Hey Nemo, are you listening? Are you talking, carrying on a separate conversation on mute? Okay, but definitely looks like Nemo's not listening in class. Okay, so someone's got to pick up his code from last class, and I don't know who wants to do it. Maybe I remember every one of you has coded. Oh, actually, I forgot whether it's Ken or Connor the other day. Kenneth or Connor? Connor, did you code?
I have, but not the other day.
Oh, I see. All right. Well, if you want to code, you can code, obviously. I don't know anyone else who wants to code today. It's going to be fun, okay? I can guarantee it's going to be fun. Hey, Nemo, are you back? Someone should tell Nemo to switch on his microphone at least. Not microphone, his speakers. I think I'm also muted on his end, so he can't hear me. So it's important that you're back in class and engaged, and especially since we'll be working on the code that you wrote last class.
Sorry. My audio wasn't working.
Oh, okay. All right. Okay, cool. Great. So you did share your code on Reddit, right? So someone should pick up the code. And I'm thinking that if, well, let's see who wants to code first, okay? And then we'll pick and choose the best candidate to code today. What I mean by best is not the most experienced or most talented, but really the person who has the best hardware, so that we can we'd be able to play the game, hopefully with some sound effects. I was thinking of some sound effects that we can build into this game, and I think we should be able to do that, provided we get a person who's got a working on in an IDE rather than online GDB. Because online GDB, we discovered the other day, if you make sounds in the program, it doesn't transmit the sounds to you via the browser. Okay, so who wants to code? So decide who wants to code, and then we can get started. Adam, you want to code? Okay, all right. All right.
I've pretty much got the code
Hey,
already.
Adam, are you also in the library room? Nemo
Yeah,
and
I'm right
you
next
were.
to Nemo. I'm right
Oh,
next
okay, all right. So it
to
is
him.
a library room. Okay,
Yeah,
okay, cool.
I've got
That's great.
I was coding along last Thursday, so I happen to have the code.
Excellent, excellent.
I
All right,
think
so let's
the only
pick
thing
that
I
up.
did differently is I added a deconstructor, which
The
we-
destructor, you added the destructor too?
yes,
Great,
there's a
great,
destructor
okay.
in mine.
All right. So we can take a very quick look at the destructor Adam has written for the benefit of everybody else who's in class, so that everybody's on the same page and we understand what's going on. It was homework, right? Everybody should have implemented the destructor, but we'll take a look at this completed code and then we'll start implementing things, right? So I'm thinking today what we'll do is also have a player class. So we have the display with effect class, and then we have the ring class.
I suppose
Let's
I
also
should
have
do
a
it on
player
GDP.
class. Okay, we'll have a player class. Player class, and yeah, okay, and we may need to make some changes to the ring class. Yeah,
I'm an online GDB hater.
don't do online JDB. Hey, Adam.
Yeah,
I thought you heard online JDB.
yeah, I'm
Do
an
you have a
online
Mac or a
GDB
PC?
hater. I'm doing cpp.sh instead.
No. We want an IDE. Do you have an IDE?
I'm talking about the IDE. You want literally an IDE. I could just use
Yeah.
what I have.
A Mac or a PC, first of all. Adam, is it a Mac or a PC?
It's a Mac. It's a Mac.
Great. Okay. All right. So yeah, just use Xcode or some IDE, and then we'll just play with it. Xcode is pretty cooler. No, not cooler. It's easier on a Mac. Well, actually, it's not. VS Code is equally easy. I think once you get used to it.
I've never used Xcode. VS Code just I didn't have that much.
Yeah. All right. You can use VS Code. VS Code is fine. If you're facile with VS Code, we can use it.
Yeah, I guess we'll just have to compile by the command.
Yeah, we can compile it together, okay, on screen, all of us together.
Yeah,
okay.
Just so we know what's going on.
All right, you can actually control minus yeah, I think that's good. I can see. All right, so this is our class, and where is the do you want to let's go over the destructor really briefly for the benefit of the other students,
okay.
and then
find it. So here's ring. Here's the ring destructor. So I suppose I should comment it. I didn't comment it as I did it before. So we're gonna start
self-explanatory.
Yeah, we're gonna start at the top, at the very first node of the ring. You know what? I can comment it later. I can explain it now. You start at the first node of the ring, and we're going to just since we happen to know the length, we can do it this way. There are other ways of doing it if we didn't know the length, but it's convenient to do it this way. So we're going to do a for loop through the length, and we're going to save the next node. And the reason is because we're going to delete the value at the node we're currently at. And if we look at our node class, where is it? It's got a pointer to this next node. And the important thing about pointers is when you store when you store something at their address in memory, this variable doesn't know, it doesn't have access to that literal memory. It just has the address that points to that memory. So when we get rid of this class, or when it goes out of scope, when we let's say we have a node inside a method that we're using, and we finish the method, that node is now gone. That pointer is now also gone. But the value, the memory that was put into the heap, the long-term storage that's outside of local storage, that is kept. So when we do a deconstructor for the ring, we have to make sure that we delete the nodes. And when we delete the nodes, we make sure that we're also deleting the node after the one we're deleting. And so we save the next one, like as a temporary variable, and then set the pointer inside the current node to be null pointer, so that like so that nothing happens to it. And then we're gonna delete the current one, and then change the current one to the next one, and then repeat that over and over. And what happens is it'll, I mean, I suppose we could add a cout statement.
Oh, I'll also add a tag. Whenever you have a, cout, you can say deleting within quotes,
right.
and then.
So now we can compile this. I never compile manually, so you'll have to forgive me if I don't understand exactly how to do this. There's no way it's. I think it's /. Yeah, I did it. Okay, so if we remember. Okay, why is it printing this? I suppose we should stop drawing the screen.
Eaters. No.
Let's disable the screen, because it's definitely deleting all 20 of the nodes and no more, because if
Sorry.
it doesn't really matter if I mean, okay, it matters most of the time to do this. In this case, since it's just one program that we run and it's done, and it's like the memory that the operating system gives to this program is I think, as far as I know, once the program terminates, the operating system says, okay, I don't really care about, what's in that memory anymore. Correct me if I'm wrong, Professor.
Yes. When the program terminates, everything that you've allocated will be deallocated by the operating system. And the only thing that for not for you, for generally C programmers to consider is that I have seen sloppy C programmers, and this is great. Okay, so I've seen sloppy C programs where people just allocate, especially people that have programmed in other languages and come to C++. They'll allocate objects, but they won't take the trouble to deallocate them, because they say, well, when the program terminates, the operating system will clean up. Okay, that is bad habit. And it is important to break that as soon as possible. We have to write a destructor like Adam has just done. And by the way, you don't need to assign a current next null pointer to current next, really, because it's going to be freed anyway, isn't it?
That's
so
true.
It's okay, but you don't need to do that. So it's important to do this, and that is what distinguishes a good programmer from a bad programmer, because you could be doing stuff in Java and Python, not have to worry about memory, but you can still look at the code and see if that person a real computer scientist programming Java and Python, or is just someone who picked up the language and doing stuff, right? And you can tell that very easily if you know computer science, because if you know computer science, you'll see code like this, where they've done something, and then Adam says, well, I'm going to clean up before I go. Even though the operating system is going to clean up after me, I'm going to clean up because this is a mess that I created. This mess was not created by the operating system. I created the mess, so I'm going to clean up. And then other stuff the operating system clean up, because the operating system also makes a lot of allocations, and it's going to create a mess to run your program. So it's better for the operating system to clean up its mess, and we clean up our mess. So this is actually great. Okay, so so that is why we need to clean up free memory like that.
I have a question.
Mm-hmm.
Could you go over like what a memory leak is one more time? I was kind of unclear on that.
Yeah, sure. Okay, so first of all, a memory leak only happens if you have a program that is still alive. Going back to this point that Adam made before, if your program allocates memory and does not forgets to deallocate it, right? Sloppy programming, and does not deallocate it, and your program just completes its job, finishes it, and dies, okay, or exits normally, there's no memory leak there, because the operating system will clean up after you. Yes? So much we've covered already, isn't it, today?
Yeah.
The operating system will always mop up after your program dies. Now, the risk is if your program doesn't die. So can you think of programs that never die? Okay, so come on, someone tell me a program that you fire up and it never dies. It always stays on. Even though you may, run other programs and all on your computer, that program, once you start it, is always on. Can you remember? Can you think of any programs that are like that on your computer? Take a guess. Take a guess.
Windows Update.
No, actually, that's not correct, Robert. Although it seems to take like a long time, and
No,
Windows
I'm
Update,
saying is
let it
it
happen
never
overnight.
it never sets off. Like it never stops.
Oh, I see. You're not talking about the actual update, but you're talking about the update daemon. Okay, all right. So, good point. Okay, that update daemon is not a separate program. It's actually part of the operating system. The operating system has lots and lots of threads that get fired up from time to time. So, all right, okay. So let's consider that. Robert maybe it's a good answer. So the operating system is a classic example. Okay, the operating system is a classic example of a program that you fire up when you open your computer. Okay, and the operating system is running, and the job of the operating system is basically to interact with you. Yes. When you fire it up, MacOS, Windows operating system, Mac, Linux, what is the primary job? The primary job is to take what the user tells it to do and then convey it to the core, the CPU, to do the stuff and get the results and give it back to you. So that's basically the function of the operating system and the shell. Yeah. So those guys are basically living programs. They are alive all the time. Even when your own little programs come and go, like this roulette game, right? We run it, it comes in, allocates memory, deallocates memory, and goes away, right? Those programs are short-lived. But there are these programs like operating systems, or like the Windows Update thread, right? These programs, they don't die. When the operating system starts, like the operating system, they continue to live on. These programs are called daemons. Okay, a daemon. If you look up daemon on in a dictionary, it's basically, I don't know if this is the real meaning. A daemon is something that doesn't die. It's always there. Right, so people have these demons in their heads. They say, "Oh, I've got these demons in my head." That's because there are these annoying and troublesome thoughts that keep coming back in a very bad way, and they just can't seem to get rid of it. Right? That's why they're called demons. Demons, you can't get rid of demons, and a program that doesn't die is called a daemon. Now, the programs can be demons, and just like demons in our fantasy world. Programs can also be good demons and bad demons. Okay, so you can have good demons that will basically come and hang around. The operating system is a good demon, yes, because it's there. It's just there in the background. It says, "I won't die, and I'm going to do my job." Okay, I'm going to do my job, and I'll do it really well, and I'll shuttle back. So that is a good demon. But there are bad demons. Okay, and especially demons that have gone rogue, meaning that you started a program which you expected to complete normally. But it didn't complete normally. Instead, it didn't die. It's just there. You can't kill it at all, right? So that's a program that is a daemon. It's always there. Chrome, the browsers are most of the time they're not demons. But even though they're not demons, in the background, demons really are in the background. Okay, demons are not programs that you interact with continuously. They're in the background. But there are programs that you interact with continuously, like Chrome and all these other browsers. Right, they're there all the time, even though you go to a shell and VS Code and run your own program, but your Chrome is always there. Okay, so in those programs, it is important to clean up every time you allocate memory. Yes or no? Because if you take memory and you don't give it back to the operating system, until you die, that memory is locked up with you. Yes or no?
Yeah.
And if you don't die, that memory is basically there. And it's not going to be allocated to anyone else. It's been allocated to you, but you have forgotten that you got the memory, right? So it's like getting a lot of resources, putting it in a bank locker, and then forgetting about it. So the resources are there. You can't use it. Nobody else can use it either. Does that make sense?
Yeah, that makes sense. Thank you.
Right. So it is not an issue. If you die, And then, you know, the bank says, okay, this locker needs to be opened up and, you know, freed up. Okay, that's okay. But what happens if that person doesn't die? You know, that resource is permanently locked. That is called a memory leak. So if you write a program that is not going to die, like it's just going to be a browser or, you know, some kind of a polling program that is monitoring things and making sure, you know, everything is going okay. This is like a ton of, you know, tons and tons of programs on your computer. Every single time you use your computer, we think that there's, you know, there's a couple of programs running. It's actually a ton of programs. If you go to the activity monitor on, you know, Windows or your Mac, you'll see a huge number of processes. They're all running, but only a few you can actually see and interact with. So if any of those processes are allocating memory, but not freeing it up, okay, that means that is a memory leak, right? Because you got something and there's no way you can get it back. It's just gone. It's leaked out, right? It's and it's been locked up too. That is what a memory leak is. Now, does that make sense?
Yes, thank you.
Yeah, and so that doesn't mean that you cannot write good programs and you know, programs that don't leak memory in Java and Python. No, you can actually write daemons and other programs in Java and other languages too, which don't actually give you the power to allocate and deallocate memory on your own. But that means that every time that memory, it's got something called a garbage collector. Every time there's lots and lots of pieces of memory that have been allocated and then you tossed and forgot about it, you didn't explicitly deallocate, the garbage collector, which you know is actually a system, operating system, it's a thread in the runtime system that will go and sweep your program's landscape and find out all these little pieces of candy wrappers lying around, memory allocated but, you know, tossed away and forgot about. It'll take that and return that to the central pool. Okay, so that means that even in Java and all these other languages, you can look at the code that is going to be running for a daemon, and you can see if that is sloppy code, because if they keep allocating lots and lots of little objects, and these objects are just lying around waiting for the garbage collector to pick up, that's bad code, right? Because, you know, all of a sudden the computer will seize up and it'll freeze for 10 seconds, 5 seconds, and so on. It'll just freeze and it'll, you know, won't do anything. Oh, Peter, maybe it's not Peter, it's someone else. No. You guys want to see? Is this coming back for more and more cookies? No. Out.
Is that a squirrel?
Yeah. You know what? I don't know if it's a single squirrel or there's a consortium of squirrels out there, you know, saying, well, you know, we'll all go one at a time, so he doesn't think it's the same. It's the same person, right? Same squirrel. So they all come at different times, maybe. And usually I give them these cookies that I got. But you know, so the ones what they're really crazy about are not cookies. They're actually acorns. Okay, that's their top. I think acorns have got some, you know, something like a drug or something in the seed. It gives them a high or something. So, you know, if I give them peanuts and cookies and peanut butter and everything, and there's an acorn, they'll just toss everything. So I got a whole bag of acorns that I picked up from an oak tree nearby. So I give them a, you know, special treat from time to time. All right. Okay, cool. All right. So everybody clear about memory leaks and all? So we can actually start coding. We can start coding this. Okay. Is everybody okay? Can we start? Okay. All right. All right. So I can't see the other people like David and Philip and Andrew, Ashley, Connor, Darshna, Kenneth. And Susilo, you've got to switch on your cameras, okay? Because not next quarter. Actually, I requested this. We'll see if it happens. I think this is winter. No, spring quarter. Spring. I said we'll have the same class, but the class will actually happen in the STEM center in front of all the, you know, IMAX. You know, in the STEM center, it's really flash. There's all these, you know, state-of-the-art iMacs in there, lots and lots of them, and it's a nice environment too. And instead of having to sit in libraries in this, you know, claustrophobic library room like Nemo and Adam, you can actually sit in the STEM center. It's airy and there's coffee and cookies and all, and then everybody will have the same Macintosh and Zoom, and you can all have your cameras on, and we can have a proper class, just like in real class. So I made a request. We'll see if that happens. But until then, okay, so you guys should just feel free to switch on your cameras, and everybody should participate. Is if everybody is okay with the coding, we will now start coding. What we want to do now is here. Well, let's keep it exciting. Let's see if we can program the effect of the rotating wheel. Okay, now the wheel is not going to rotate like this. Okay, this is a roulette wheel. We're not going to make it rotate like this. We're going to see the sideways projection, so the numbers will rotate like this. Yeah. So in other words, you'll see the numbers rotate. Yeah, well, the effect will be much better, I think, when we look at it rather than me explaining. Okay, you're going to be seeing it like this. So you'll see 1, 2, 3, 4, 5, and then the whole thing will roll around. Okay, so the one moves to the left, and one actually come around to this side. Okay, and everything will rotate like that. So you'll actually see the numbers. I think that's how it looks in my mind. Yeah, oh, you want to write a display with rotating effect? Okay. What we'll do is before we do that as a display with rotating effect as a member of the display with effect class. Oh, I see. No. Before you do, let's actually do let's do that in main in code, because I haven't actually implemented it yet. But let's do it as a 10-line fragment in main. We'll make sure that the effect is there. Okay, once we have the effect and we're happy with it and we've tweaked it to make sure it looks nice and all, then we can move it into a method of its own. Yeah, is that okay with you guys? Okay, and I think it'll be easier for a lot of people. So now, all right. So let's. Can I take a look at the main again, please, Adam? I want to see
This
what
is the main. It's just a lot of
Oh,
comments.
that's our main. Okay, all right. So in main, what did we do in main? How many? So we have a ring of 20. Okay,
On the
display.
right?
Does this, by the way, we had 20, but only 16 numbers showed up, right? So can you run it one more time, please? Can you run it
Yeah,
one more time?
I was about to check that out. Okay, so what is it doing wrong now? Not on the screen. It's not great. It shouldn't be. I actually don't know what it's doing now.
I'll take a look. Let's take a look at main. It must be happening in main. Okay. So what is this? What is this method, by the way? Is this main?
This is main.
This is main. Okay. All right. So string OS.
Oh,
Hey, good. I was thinking that OS. I think we used the word is before, the variable name is before, but it was an output string. I was thinking, wow, you know what? It should have really been called OS. But Adam actually made the change.
Yeah,
You made the change, right? Because I don't remember that it was
on my
OS
end
before.
as I wrote it.
Yeah, thank you for that. Okay, so you create the OS, and then all right, and then you for the ring size you print this os.str. Get rid of display or I see. No, that looks all right to me. Why is it not printing? Why is it not printing?
I'm confused.
Just run it one more time. I don't know if you did run it one more time.
Recompile, just to be sure.
You did run it, yeah. All right, just print a C out inside of your main before you enter the for loop. Just print a C out. So I'm doing the poor man's debugging here. We are debugging the code, but hey Joshua, welcome to class, and please try to make it on time. Okay, there's only one more class. Okay, there's only one more class on Thursday. I'm happy to give you a class next week also if you guys want. I don't know if you guys want it, but hey Joshua, are you there? Are you now synced into the class, or are you still setting up?
I'm here.
Okay, good. Right. So yeah, try to make it on time, everybody. Now just put a cout statement, hello or something like that, and run it, compile and run it again. Let's make sure. Yeah. So what I'm saying, what I was saying was that I'm using the poor man's debugger. The cout is called the poor man's debugger. It is actually the best debugger in the whole world. Okay. Even though you have all these really, really sophisticated debuggers, the best ever debugger is basically a print statement, right? That is for people who know what they're doing. Right? People who don't know what they're doing, well, actually that's not true, right? Because even people who know what they're doing, they need to step through the code sometimes in a debugger. But most of the time, if you think about it, as and when you get more and more experience, you'll find that firing up the debugger and stepping through the code involves a bit of effort. Like maybe two minutes more work.
Could be too fast.
Yeah, 2 minutes more work. But a cout statement, if you know exactly what you need to test, takes like 2 seconds. So that's why a lot of experienced programmers, they actually prefer to do printfs and cout statements to debug their code first, right? And if that still is insurmountable, then they go and try the debugger. Okay, so it does print hello. Okay, now put the hello inside of the for loop. Now it should print it 20 times. Yes, it should, because the ring size is 20, isn't it?
Yep. Did
Okay,
that
yeah, all right.
correctly, which there's a good chance I didn't.
Okay, it does. Okay, so it's just not going into the output stream. It's not going into the output stream.
Is it not? Because it did print
Doesn't
it
seem to be
before.
going.
Like, here, oh, I cleared the terminal. Why did I do that? I wish we had, I mean, we did have evidence. Like, before we even fiddled with the deconstructor at all, it did work.
Yeah, it was working. It was working before. So why is it not going into the
I
output
don't
stream?
know.
That is the question.
I mean, I just did a little debugging and the C out statements work out until draw screen. So I'm gonna go into draw screen and see.
Just change the OS into C out. Just change OS into the C out inside of the for loop. Inside the for loop. Just C out instead of OS. Yeah.
Okay.
Okay. Well, all right. So it is doing something. It is doing absolutely. So it is just not coming out of the O stream. Why the hell is it not coming out of the O stream? You need to initialize the O stream with a blank string or something. No, just say open parentheses after O stream and say blank string. That shouldn't really matter.
Usually I just use
but-
string frames for this function. I mean, I don't know what, like, if, I mean, yeah, I mean, obviously
You
there's.
can get rid of the inner C. You can turn the inner C out into OS again, into an OS. OS. All right. And now, yeah. Now, okay, good. Now go to that place where you had on line 107, 197. Hit enter on line 197. Yeah. Now send hello into OS. Send hello into OS. OS. Hello and endl. Now get the string from OS, and right after that line, just print C out. Yeah. No, get rid of that hello in 207, line 207. Get rid of line 207. Okay.
Oh, I
What?
didn't recompile after I made the change.
Okay, so why is it printing 2 hellos now?
Because it's drawing the screen somehow. Wait, wait a minute.
Oh, I see. Yeah, okay.
Yeah, that's it. Wait.
Okay, so it is coming out. It is coming out. It is coming out of the O stream, but why is it not getting stuffed into? So that means ring.size is probably 0. So can you print ring.size after the C out on line 199? Hit enter. After the C out on line 199, hit enter and say C out ring size equals. Why? That is probably one reason why it couldn't.
I mean, that's what I'm thinking. I bet you it.
No, I think it was a function. You use a function for ring size, isn't it?
Yep. 20.
Yeah, okay. Ring size is 20. So I equals 0, I less than ring size, I plus plus.
So it's definitely drawing the screen. It's definitely drawing the screen now. All of a sudden.
No, it's not. I'm not seeing it draw
It
the
is.
numbers.
This is the one that this is the one of it drawing the screen. I mean, it's just not drawing the numbers onto the screen, but it's drawing the screen. So it's just not.
Oh, print a new line after draw screen. Print a new line after draw screen. And endl after. Yeah, C out endl. Yeah. I don't think that's gonna make a huge difference because. Oh wow.
Did I not?
So it feels. I think what.
Flush in my.
No, that's okay. That's okay. See out flush and so on. Let's take a look at the main again. Main. Right. String s os.str. Display draw string. If you comment out line 215, it doesn't. Comment out line 215 and it doesn't come, right? Comment out line 215 and then run again and it doesn't work.
So here's what I bet. Oh, okay. Yeah.
First of all, get rid of the hellos. Where are the hellos? Get rid of the
hello
hellos.
is actually only this one. It's putting it to the O stream, and then we're printing it from the O stream, and then it's still part of the string when it gets added.
Oh yes. So we can, if you get rid of the first one, then both of the hellos will go. Yeah. All right. So now run it again. Let's see if we get the numbers along.
we don't even need this NL now. Or I don't know, I mean, we might actually still need this NL. Yeah,
No,
we do.
see, now, put the NL back. Now, let's see.
That's so crazy. Oh, because it's not.
Okay, why is it not
completely
flushing?
slash
Why is it
R.
not flushing?
Okay, because it's slash, there's no.
Oh, I think I
Um,
know what's going on. I think I know
it's
what's
just a
going on. Yeah, I
flash
think I know what's going on.
line.
Okay, I know what's going on. Okay, all right. So it's very subtle, and if you guys want to take a crack at solving this puzzle on your own for how many 2 minutes? Okay, I'll give you guys 2 minutes. I don't know if you can. It's going to be fun. Okay. This is my hypothesis. I don't know if this is my hypothesis, and we're going to test it. Okay. And I can tell you my hypothesis why it didn't work. If one of you wants to take a crack at it before that, be my guest. Otherwise, I will tell you what I think is going on. Okay. Does anybody want to take a crack at why it's not working? No. You want me to tell you? Raise your hand if you want me to tell you. Okay. Otherwise, I'll think that you're still trying to figure it out, which is great. So some people are still trying to figure out. Yes or no? What do you want me to tell you? All right. Okay. Well, I'll tell you. All right. So here's my hypothesis, and Adam is going to do a test, and I'm not going to tell him what the test is, but he can figure out the test easily. So this is my hypothesis, and you test to find out if my hypothesis is correct. Okay. Now remember, in our cout statement out there, when you just draw the screen, you're drawing the contents and hitting and printing a /R at the end. Yes or no? Okay. So what happens is that it prints all the numbers, and then it goes back to the beginning of the line. Yeah. Okay, now that's where it is. It didn't go to the next line, it went to the beginning of the line. Okay, that means when the program says I'm done and hands over control back to the operating system is going to print the prompt for the next line. I say, well, all right, what is your next command? And it's going to print the prompt on the same line. And so the shell is going to clear the current line and print the prompt right there. And that's why the numbers got printed. And then it kind of freaked out. So you can test. How can you test this? By the way, how can you test this? So one way to test it is after you draw the draw screen, you can just do a cin, right? Don't do a endl. You can do a cin to accept input from the user, and I bet you'll be able to see it. And then when you hit cin greater than some variable, some integer or something like that. Something.
I don't know if we
have some string. You got a string variable out
we
there?
have S. Okay.
Yeah.
We've got S. Just it works.
Yeah. Okay. Just yeah. I think this should test it, and if my theory is correct. Okay. All right. So that is exactly what was going on. I'm actually very super duper glad that we started the day with a successful testing of a scientific hypothesis, right? So mysterious behavior. We didn't know what the hell was going on, but we kind of figured out with the cout statements that the reason it didn't print the output was because it printed the line, and then after it was done, it went back to the beginning of the same line. And then the operating system came back and printed the prompt for the next line saying, well, Adam daily at Adam's MacBook Air -3 and a colon. And it printed it on the same line. And that's why that line got disappeared. Yes? Does it make sense now? So the way to not make that happen is essentially to say, well, you know what? Before my program exits, it's going to go to the next line and exit. Okay? That means that after that's done, it will, it won't. The operating system will only clear the next line. It won't clear that line. You can Control C out of it. We just need an endl at the end, so to make the operating system go to the next line, right? So I think it is working.
Before we do anything, I'm noticing that we're only getting 16.
Yes. All right. Who can tell me the reason for this? Okay. So again, it's really cool. And someone tell me the reason for this. If not, I will tell you the reason. This time it's not a hypothesis. I know what's going on. Okay.
Is there not enough space on that line to fit it all in? Like it's getting
very close to the answer, but not yet. So when you say not enough space on the line, but I actually see a lot of space, right? I see a lot of blank space after the 16 on the right. So what do you mean?
I just maybe the way we have like the limits for our display set, like there's just not enough characters available within our display size to print.
Yes. So that's exactly what it is. Okay, Alex, right? So our display width is 80, right? So if your string is more than 80 characters long, it's not going to draw it. And here it is actually more than 80 characters long, because 16, this is 2 digits plus 2 spaces on each side, plus one of those guys. Okay, so that's already like 5 times 16 is, I don't know, 5 times 16 is 80, right? 16 5s are 80, isn't it? I'm not getting any responses from you.
Plus
Yeah, it is.
2 plus.
Yeah, 16 5s are 80. That's why I printed 16, and that's the end of the. So all we need to do is basically turn the width of the display width of the screen in your display width.
We just do in the,
make
we
the
just do when
default.
we
Yeah.
Just
Great,
use
great.
add
Make
20,
that.
right?
Yeah, 100 will give you all of them, I think. Yay, okay. Actually, make
actually
that.
not quite.
No, you don't need a. Why is it not printing the last bar?
Is it not big enough?
No. The last bar is being printed by. Oh, is it? Okay, run it. You'll get the last bar now. But where was the last bar being added? Was it being added in main or in the yeah? Okay. No, you are adding it in main. So why, even if you're adding it in main?
It's this amount times whatever, it's the math you did plus 1 because there's an extra one.
No, that's not going into the. That's going into the output stream. It's not going into the ring. Yes. So that should come out regardless.
It's never going into the ring.
Hmm?
It's never going into the ring. The way we wrote
Yeah,
it.
it's not going to the ring. It's going directly into the output stream. Yes.
Yeah. This is just a visualization just to make sure that our ring is sorted.
Oh, yes. Okay, all right. Oh, you're getting the string and okay, good.
But it's not.
So if you print the string, if you print it explicitly, it'll work. Well, yeah, 101 should work. 101 should work. Yeah, excellent. Thank you, Adam. Thank you for your patience. Bearing with me and all. Great. All right. So now what we want to try and do is in our main, you can get rid of lines 210 to 213 because that was stuff we basically stuck in there to debug. And you can also clean up more. The cout statement above can also go because we want to reduce the size of the code too, because this file may end up getting too big otherwise. Okay.
I don't care how.
That's okay. That's okay. All right. So what we want to do now is in our main. What's going on?
Just deleting some files that we don't want.
Right. Oh, I see. Just cleaning up. Okay. So in our main, what we'll do is after 205, after 206 in an end, what we want to do is print it like we did before. However, after printing, we want to change. That should be in a loop. Okay, we want to change the current pointer to point to the next guy, and repeat the same thing again. So again, it's going to do 20, but starting at the next number. 20 starting at the next number. So it's going to do that. But after every printing, we're going to sleep for, I don't know, was it 50 milliseconds? We'll sleep for 50 milliseconds. Okay. So yeah. In fact, we want a containing for loop. So what we'll do now is for size. Actually, no, we'll do a containing while loop for now. Okay, we'll do a we'll do while true, and then we can change the while true later on. Okay, while true, and inside we want put the whole thing inside of the inside indent the code inside. Yeah, all right, good. You can also remove the blank line on 203. 203. Yeah, because you can stick that together. All right, good. Okay, now what we want to do is say, and move that the node star cur equals ring dot first to outside of the while loop, loop.
Right.
Oh, you can do that in VS Code. You can just drag a line like that.
No, I'm just holding the Alt key or the Option key, and then I'm pressing the arrow keys.
Oh wow!
It actually has a lot of fun.
Yeah, that's really cool.
Option,
That's really
and
cool.
then if I hold the Control key, or actually Command on Mac, Control on Windows and Linux, it selects multiple spots, and so I can actually edit all of these at the same time.
Oh, nice. Okay, great. All right, so while true, all right, so now current equals current dot next, and after current dot next, let's sleep for 50 milliseconds, okay? Let's sleep for
I
50
don't know if we have
milliseconds.
sleep. Do we have sleep?
I think
Have
you have UNISTD, so we can just do a micro sleep, you sleep, you sleep. You can do a you sleep on the next line. You can say you sleep. No, lowercase you lowercase you sleep. And then inside say 50 times 1,000, is it? Oh, I don't know. Someone tell me 50. We want to sleep for we want to sleep for 50, half a second, right? Half a second is 500 milliseconds. 500 milliseconds is 500,000 microseconds. So 500 times, no, 500 times 1,000. 500 times 1,000 microseconds. 500,000 microseconds is 5 milliseconds, isn't it? No, 500 times 1,000 is 0.5 seconds, is it? 0.5 milliseconds. Oh, geez, I'm like totally screwed up here. What we want is a half a second. Is that a half a second? Yeah, that's, yeah. 500 microseconds is half a second. Okay, now get rid of the endl thing there. No, let's get rid of the endl, that line. And then instead of that, I'm sorry. No, yeah, there you go, endl, and then displayer dot, yeah, okay, good. Yeah, and then you can do displayer dot and draw string at 0, and then os.str, comma 0, semicolon, and then you can get rid of the blank lines after that too. And then the you sleep. Oh, you can leave it there. That's fine. Now I want to run this in my head before you run it. Okay, so it's gonna make the string, print it out, draw the screen, and then it's going to go to the next guy, and then sleep for, and then do the same thing over and over again. And it does have a flush, so we will actually look at this thing moving. I think, hopefully, right? Fingers crossed. Let's hope it works. Okay, so let's run it. Now, why is it not moving? Oh, bummer. This is like core to what we want to try and do today. So we want to figure out why it's not moving. All right. So
It's
current equals current dot next.
That's messing it up, actually.
Hmm?
Type a little bit. It's definitely doing stuff. Like
No. Here, I think. Wait a sec. Right after that draw screen, just do a cout endl. I want to see if it actually does it on multiple lines at least. Okay. So run it, and then you have to hit Control C because it'll just keep scrolling fast. Oh, it's not even moving. It's not moving at all. So why is it printing the same thing over and over again?
I don't know.
So current equals current dot next.
Oh, current
and then
current. It should be set to current first, right? Well, it could be current next, isn't it?
Yeah. Current equals current arrow next. Did you do current equals current arrow next?
I've got an idea.
Oh no. Inside of that, you have to do current equals current arrow next, isn't it?
I just had that.
Oh, you did that.
Just had. So I'm suggesting we have a separate variable for like where we like start, and this one is set to where we start every time we do the for loop. And then instead of changing current, we change the pointer or whatever, the arrow.
Okay, don't call it current then. Call it start. Right? Call it start. Call it start.
Yeah, I'm just creating two nodes now, or node pointers now, and then this one is ring first. It's actually start.
Oh, that's why it didn't work. You had that inside the for loop. I thought it was outside. So no, you can get rid of all of that. Yeah, Command Z out. Oh, you didn't have that inside. You didn't have that. Right. Current equals ring dot first. Okay, and then it makes a thing and it prints it, and then current equals current dot next. Do you have current equals current dot next? Yeah, you have current equals current dot next. Now, and then it goes back, and then it.
I think what I just had would work. I think what I.
Right, but I'm still puzzled as to why that other thing didn't work.
I'm still puzzled too. I mean, if this doesn't work, it's the same issue. No, it doesn't. Okay.
All right, so it just didn't work. Okay, so wait. Okay, so why is it not working? All right, so ring dot first.
Truly point to the first one in the ring. Do
Yeah,
we-
it's pointing to the first one when it hits the for loop, so it prints all of those guys, and then it goes to the very end. Oh, of course. Yeah. Oh my God, this is basically a logic bug. Okay, we should have figured. I think I should have figured it out. Okay, because you guys are just right. So it goes to 20, and then it goes to 20. At the end of the for loop, it's going to point to the last element, and then current.next is going to reset it back to the first one. So it's always going to print the first one again. Yeah. So all we need to do essentially is, yeah, we need to have what Adam was doing. We need to have the second pointer and only the second pointer. Yeah, current, only current, and then, oh yeah. So inside the for loop, inside the while loop, before the for loop, right? Before you start the for loop, yeah. What you want to do is node star. Yeah, you can say start. You can say start. Node dot start. Node dot start equals start equals start arrow start arrow first. Okay, and then
You mean ring arrow first.
no. Start arrow first. Start arrow first.
There's no first
Start arrow next. Start arrow next. I'm so sorry, guys. I'm confusing you. Right on the next line, you're going to say current equals start. Current equals start, and then move that start thing to the outside of the for loop. Right outside of the while loop.
This is what I had before. So it's this one's current. This one is start.
Oh, that's what you had before. Yes, I wasn't even looking.
So this is what I was trying to. This is what I was trying
No,
to.
yeah. I think that's correct. That's correct.
This one
Yeah,
doesn't.
that
This
should.
one still doesn't work.
It didn't work.
No, this still doesn't work.
Okay, all right. So start is ring dot first, and current is current equals no, just say current equals start right there. Current equals start.
Yeah, now
not
we can just say current equals start. We don't have to say start next.
current equals start. Okay, and then at the end you say start equals start dot next, and that has to. I can see why that shouldn't work. Okay,
Doesn't.
so let's run it now.
I tried it. This is what the result of that previous one is. It still doesn't work.
Okay. All right, great. We have a juicy problem here. Okay, we have a juicy problem here. Fantastic place for us to learn something. So this is something we all have to debug together. So let's try and figure out why it's not working, right? Because at the end of the day, it's not the completed project. It's all these places where we get stuck. Those are our learning points. Okay, so right through current equals start, and then you print the ring starting from that, and yeah, okay, that is correct. Current equals start in there, and then you print that, and then you do that, throw the screen, and then you should start at the next guy. And why are you not starting at the next guy? So before on line 215 or at line 215, put two cout statements, one before and one after, saying cout start is now this, and then afterwards start is now that. So we need to see those two things. So put on line 214, or just put a cout on line 215 saying this is what start is. All right. On line 215, hit enter. Or yeah, line 215, hit enter, and you say start equals cout start equals
Cout start equals
start. Yeah, no, within quotes you say within quotes you can start equals, and then you can say start arrow num. This is start arrow num, whatever that thing is. Start arrow num, and then endl. Semicolon out of yes. Now wait a sec. Okay, start, and it's going to print that. Now we should see that start has gone to the number 2, right? After the first loop, it should have gone to number 2. So let's see if that happens. Okay, all right, good. So that's correct. So kill that now. So current equals start.
Is it because it doesn't exit the for loop until everything is?
Oh, I think I know. All right, I figured it out. Okay, I've solved the problem. Anybody else want to solve the problem too?
Is it because it doesn't exit the for loop until everything?
No. All right, good. Well, good guess maybe, but that's not the reason. Well, I'm so cool. I'm so happy that I found the answer. So which means we'll have the answer. Okay. But I want to give someone else also a chance to figure it out. If not, again, it's a hypothesis. We'll test it. Okay. But I think I have a very good hypothesis why this is not working. Okay. Anybody else want to take a crack at it? No? Raise your hand if you want me to, test my hypothesis out.
I mean, It might be, is it slash R?
Adam wants to
related?
try something. Adam wants to try something. Okay.
I feel like it's slash R related, because we never really had a chance to play with slash R, so I never actually, I don't actually.
Okay, so I think here's what's going on, okay? We didn't clear OS, so it's getting more and more stuff added on to the end.
Oh,
And so it's only printing the first part, which is always that. So all we need to do is just say os.clear. Oh yeah, okay, that should work. That should work, okay? And I think that will work. There you go. Okay, good. Now you can get rid of the cout and all at the end. Cout, endels, you can get rid of the whatever that thing is, making it go start equals, and I'll get rid of the start, the debug lines. Yeah, get rid of that. Yeah, get rid of that line.
way too far.
Okay, and then I don't think we need the cout. We don't need the cout. Endel, cout endel.
We don't need that either. I bet you this actually just. Oh, yay.
Okay, all right, good. All right, so we got it. However, however, it's not so visually nice. No, I think oh yeah. Okay, we don't have to play around with the duration, because the duration is going to change dynamically, right? We'll change the duration dynamically. So all we need to know is that it's working, but it's not a good visual effect. So we'll try and make the effect more nice. I think what we'll do is in the displayer. What we need to do is when we display, we need to display it at we shouldn't advance number by number. We should just advance one character at a time. So in the ring, so we got the string, and then the string should just advance one character at a time. All right, so here's what we'll do. Okay, so what we'll do is it rotates around. Gee,
Well,
I should have thought about this more.
we could-
Well, we can leave this.
do it in
We
one
can leave
bit.
this.
I mean, okay, we could do it whatever way you're thinking of doing it, or we could do it the really simple, dirty way of just splitting our U sleep into several U sleeps and then just advancing this.
Yes, that's what I was thinking. That's what I was thinking. However, when we split it, we still want to have character level movement, not number level movement, right? Because numbers
Right.
move from slot to slot. It doesn't look like animation.
So like we do like a U sleep of 100, and then like, I mean,
All right. So how about 60 seconds? Okay, 60 seconds. You guys and Adam can think of something, and I will also think of something. Okay, and then we'll resync in 15 minutes. By the way, before I do that, I want to make sure that everybody's on the same page, because we're doing a lot of stuff. What I want to make sure is that everybody is finding these places where we get stuck valuable. Okay, the whole project, I don't care if it's valuable or not. What we need to find, what I think is valuable, is places where we're getting stuck when we're coding, because those are the places where we actually learn stuff. So are you guys happy with that? Yes or no? Because the process of debugging code is how we learn to program, not by being given a fully working example. Yes? Okay, all right, good. So all right, so I'm gonna think of how we can make this better. So what we want to do is and you guys should also try. Okay, and display with the fact gets a string, and
I have a question. Is you sleep in microseconds? Is you sleep in microseconds?
You sleep is in microseconds. Yeah, no, yeah, microseconds. Your 500 microseconds is a half a millisecond, a half a second.
Half a second. Okay, thank you.
Yeah. All right. So we have. Yeah. So what we want is that string to the string itself to roll around. So what we need is, I'm thinking I have a solution. Okay. I'm thinking what we need is a separate method in display with effect. Okay, display with effect, which we'll call this method. What are we calling our method so far? Yeah, display with rotating effect. Display with rotating effect, which is what Adam started to do. But we'll also have a second parameter, which is how many spaces. Okay, how many spaces? Okay. So yeah, and yeah, size t, num spaces, and also we want to say the easing, the how much time to wait between these guys. We don't want it to be a constant time. We want it to be slowly and gradually reducing. So what we'll do is we want to pass a starting interval of how much time to wait. So initially, when the wheel starts spinning, it'll spin really fast, but slowly gradually it'll start slowing down. Yes. So what we'll do is we'll pass in a number to this method saying you have to wait for, I don't know, let's say X seconds, and X seconds, it'll wait for X seconds before rotating the first, doing that. And oh, but it has to rotate the whole string. So in order to rotate the whole string, what will it do? It needs to take a copy of it because it can't alter the original string. No, it can't alter the original string because you make a new string and send it the next time, right? So it'll take that string, it'll print it out, it'll wait for X seconds, then it'll rotate the string by 1 character, right? And then print it out again. And then now it's not got to wait for X seconds, but it should wait for X times some, it's got to wait for X times 1.1, slightly longer. Okay, X times 1.1, 1.2, and so on. So any number you give it, it's going to wait for a little bit longer than the previous time. Okay, all right, good. So don't call it easing because that's some people may get confused. Initial wait time, call it initial wait. Yeah, in initial interval, because initial interval, init underscore interval. Or I don't know, initial underscore interval, because init means init. So initial. We'll turn that adjective. Okay, all right. So in this method, what we're going to do is draw string at. In this method you can say draw string at 0. All right, draw string at 0 first. Draw string. Oh yeah, let's do a for loop. All right, inside this method on line 97, hit enter. Line 97, hit enter. Yeah. Now say for size t I equals 0, I less than num spaces, I size t I equals 0, I less than num spaces, I plus plus, because that's how much it's got to rotate. Yeah. Okay. And in here, what we're going to do is first draw string at 0, right? So draw string at 0. No, I think you have s comma 0. S comma 0, draw string. I think draw string at. What is that method called? I keep forgetting. Okay. What do we call that method?
It's S and then I, right?
No, S comma 0. We're gonna start at 0, right? We always print the string at 0.
Okay,
now on the next line, where's it gone?
It's this method.
Where are you quoting? I lost my bearings now. I see.
I forgot to make.
No worries.
Why is it not giving me intelligence?
It's not autocomplete?
No, I don't know why it's not. I think it's probably because of this stuff right here.
No, it picked it up now.
Yeah, it picked it up.
All right. So after draw string, hit enter. Draw string at s comma 0. Now what we want to do is rotate the string, right? Rotate the string, and the way to rotate the string is by shifting all characters. So we take the first character and put it at the end, and then so what we want to do is we'll call a method called rotate string. Okay, we'll just call a helper method called rotate string by 1, right? So rotate string by 1. That can be a global helper method. It doesn't have to be part of display with width, right? So right there. But we'll call it. We don't have to implement it now. We'll just call it, and then we'll implement it later. All right. So all right. On the next line, you say rotate string s comma 1. Okay. Now you can sleep. You sleep. Initial interval times. Now we want to sleep for slightly longer each time, right? So how about we say times 1.5? Okay, times 1.5. Oh wait. Initial interval times 1.5. We want to make sure that you don't have any truncations because of integer and all. Initial interval times. Oh, actually, you can say interval times. So interval time. Yeah. All right. So before the for loop, you can say oh, actually, no. Right there. You can say initial interval equals. You can just reassign, right? You can after that line, you say initial interval star equals 1.5. No, you can't do that because you also need to increment I. So keep that as I plus plus. No, that should just be I plus plus, because that mixes up the for loop and it makes it really hard for people to debug, right? Just say I plus plus there, right? Now here you can say initial interval. Yeah, there you go. I think as long as the interval is big enough, times 1.5 shouldn't result in truncation errors and all. Okay, now let's implement just above that. We can implement that rotate string method, right? Rotate string method, right? And you can say void, void rotate string. And then you get given a string parameter, and then I think you have a namespace using namespace, so you can just say string. Okay? Your string space s. Oh, you want to pass it as a no? You can. Oh yeah. I see. Yes. You have to pass it by reference. Thank you. All right. So, by the way, Adam is making these changes, and he probably has a lot more experience now, or already has a lot of experience. But I want to make sure that that change he made just now, most of you wouldn't even have seen it. Yes, because I saw it because I was looking at this code, and some of you aren't looking at the code, and he put the ampersand there, and most of you probably missed it. Yes or no? Hands up if you missed it. Did you see Adam put the ampersand there? No, right? So, but it's important. It is like crucially important, because if we didn't do that, when we do this thing, you won't see any change, because you get given a copy and you change the copy, and the original didn't change. So we have to pass by reference. Again, this is a great learning point, right? As I'm loving this project, and as I'm loving this class, because we're running into all these little things, and each one of these is a learning point, and each one of these has points for your exam, because in your exam you might actually get a method saying, why doesn't this work? And you can say it doesn't work because there's no ampersand. Okay, this didn't get passed by reference. That's why it didn't work, and that's one of the options you got to select. Yes. Did you get questions like that in the midterm? Well, I'll make sure questions that are like that in the, there are questions like that in the final. But this is like super important, because these are the things that make you a real programmer, a real C++ programmer, rather than someone saying, well, I passed this in a computer, right? So, right. So everybody okay? That's why the ampersand is important, because we're trying to change the actual string.
I'm gonna ask a question. So
yeah, go ahead.
I also realized this in one of the quests. So what I understand is that the N, like before the S, there is like an address. So I mean, on my, what is
which N are you talking about?
96.
You said the and.
The and okay.
Yeah. And
no,
before the S. So that's like an address.
Right,
so like, why do you need an S if you can just say S? Or is that like,
okay,
you're referring to
address,
like a certain input?
good point, Susilo, good point. Okay, ampersand does mean address in other contexts, and I'm very sorry about C++ in general, because not sorry in that sense, but sorry it's confusing you, because there's two different senses, two different contexts in which the ampersand can be used. Okay, if you use it in other contexts, it is an address, like you said. Okay, but if it is given as an ampersand in front of one of the parameters, okay, parameters in the declaration of a function, that means that parameter is passed by reference. Okay, there's two different meanings. Yes.
Passed by reference?
Yeah.
There's
Do you know the difference between passing by reference and passing by value?
Passing by value means basically the value of that variable.
Yes, you will only get the value of the variable. You won't get the actual variable, right? But if you pass by a reference, you get the actual variable itself. If you change it, the other person will see the change.
Oh, so we don't need to redeclare something, like, for example, if I have like a string s in the parameter, I need to like declare like let's say A, and then I can put the s into A, but like with the n, I can just use the variable s itself that is already has a value.
I'm not sure I understand what you're saying, Susilo. What
So,
Adam
yeah.
is trying to do something.
In the alternate rotate string, if I want to have a variable with the string s, I would need to create a new variable. I cannot just say s equals. I mean, I cannot just say, wait, actually.
No, you can, you
cannot-
can. You can change, you can change s, but the only thing is when you in the alternate version, s, what you get as s is already a different way there. It's not s anymore. You can call it anything else, right? It's a different variable altogether. If you make changes to it, s is not going to be. So s is here. You pass s to that function, right? If it is passed without the ampersand and that function changes s, this s is not going to change. However, if it was passed with ampersand, that s, that function changes s, this guy also gets changed. They're the same.
Oh, it's like a global variable.
Yes, yes. Okay, it is a global variable that's only visible to these two functions, right? So in that sense, it's not a real global variable. It's a global variable that's visible only to these two functions, these two places.
Okay. So to
Does that
change,
make sense?
so to change whatever is up here, we can only we can just change the s in this function, and then it'll change everything as in everywhere else.
Yes. It will change the s in the calling function. It'll in the function that called it, that the variable gets changed there itself. Now Adam is writing something here.
Okay.
How would you do that? Yes, yes. Okay. So there you see what Adam did there is how you would do it if you didn't pass by reference. Because if you didn't pass by reference, the alternate guy is going to change the string. But after it's changed it, how do you get it back? Because it's changed its own private copy of the string. So you have to make it return the changed string and assign it back to us. Otherwise, you don't get it. Does it make sense? That's what Adam put there as alternate rotate string. Yeah. So Silo, are you clear? Are you good now?
Yes, I'm good.
Okay. Everybody okay? Can we proceed? Yeah. Okay. All right. So now let's go to our rotate string. And in our rotate string method, let's complete our rotate string method. And here, what we're going to do is let's say char c equals s square bracket 0. First of all, the first thing you should do is if s dot length equals 0, just return, right? If s dot length equals 0, s dot length equals 0, return, just return right there. Okay, because you don't want to access something that is not belong to you and you'll get killed by the operating system. Okay, good. Now we know that s of 0 exists. Now here is what we're going to do. So for rotate by 1 each time. Yeah, I think that should do. For no, let's not do that, Adam. We'll just stick to, because that other alternate version of the for loop and all this, everything we do in class, there's probably many different ways of doing it, which you'll pick up as you get more and more experience in C++. You'll find out all these alternate ways of doing it, but those alternate ways are not necessary. Oh, wow, why is it? Oh my gosh, I unplugged it because Peter was here. I got to plug it back in. Hang on. Why did it die so soon though? Wow, my battery must be totally dead then, because I unplugged it and like 10 minutes ago, and now it says low battery. Okay, so what was I saying? So we rotate the string. Okay, so we get the first character. Now all we're going to do is move all the characters in the string for size t I equals 0, I less than s dot length, I plus plus. You want to say s square bracket I equals s square bracket I plus 1. Okay, and then you want to say I less than s dot length minus 1. Okay, we want the last, except the last character. No, yeah, there you go. And then in the for loop, no, that's all. In the for loop, you want to say I less than s dot length minus 1, not s dot length.
S dot length minus 1.
And then you can get rid of the braces and all. We don't need the braces. Yeah, there you go. Thank you. Right. S dot length minus 1.
I'm not typing all of this. It's just taking my control. And
don't worry. Yeah. Equals C. All right. That's it. Okay. So now I can explain this code. Do you want me to explain this code, guys? Yes or no? Or can you follow this? And so someone else wants to explain this code, I'm happy, right? If someone else wants to explain what that code does, I'm happy with that. It'll be great, actually. If not, I will explain it. Okay, here's a chance. Does someone else wants to say? So here's, by the way, this is what we want to do. Let's put comments on top of this function saying what this function will actually do, right? So no, on top of the function itself, Yeah. Yeah, there you go. So this rotate string s by s characters by shifting all characters one step to the right. Okay, one step to the right. One step to the right. Is it one? No, n steps to the right.
What you were saying?
N steps to the right.
So n step. I lost what you
Yeah.
were saying.
Oh, rotates the string s. Rotates the string s by n character. Rotates the string s by shifting n characters to the right, and on the next line, let's say and moving the characters that fall off the right end back into the left. Does that make sense? That is what we're trying to do. We have a string, we want to rotate it, so we're going to shift all the characters one to the left, like, I don't know if you're doing and I think it's called Hilbert's Hotel or something like that. The hotel that can take infinite number of guests.
Yeah.
Have you heard of that?
Yeah.
The infinite one, like
How to count.
Right?
The very
So
hotel.
we don't know. It's gonna have an infinite number of rooms. Okay. So a new customer comes in. All we say is everyone go to the room next to you. Right. And so even though the hotel is completely full, because it's got an infinite number of rooms, everyone just goes to the next room. Right. And so the first room becomes free. Okay. So that's how you can keep on fitting people inside the hotel with infinite rooms, even though all the rooms are full. Okay. So that's what we're doing. So all the characters move into the next room, and the last character moves into the first room. Okay, and then we do that n times. So it rotates n times. Now, is it
n times, though? We've only done it one time. We just need to do it n times.
Inside the for loop, we're doing it one. As
This whole part is just one run through of shifting it. It just shifts it one character.
which part?
All of what I have
The entire-
highlighted just shifts. it one.
Oh, I see. Oh, I see. We're only doing it one. Okay, so we need to put that in that loop. Yeah, and for size ti.
And,
Thank you, Adam. Right? Yeah, J less than n.
Also, isn't this rotating to the left?
no, because
Yeah, I realized that, but I think it'll be easier. Thank you, Susilo. Right? We'll just keep it like this. Well, let's say the casino guy is left-handed and so right-handed, it spins the wheel the other way. Yeah, the effect is going to be the same, I think. Okay, so now we have that, and then you have the inner loop, and it rotates by one. Yeah, okay, all right. So I think it rotates by one character. Yes.
part of it.
No use sleep there. It's just going to rotate the string. It's just rotating the string. There is no use sleep there. Now, in the place where you call this, there you have the use sleep. Yes. Where do you call it? And so, where do you call rotate string? Okay, here. There, and right underneath. So that is going to rotate the string by one, and then use sleep, and then rotate by one, and then use sleep again. Yes.
Yeah, that'll work. I mean, I don't see why we're doing this in a for loop when we could just like do this all in one operation. Then, if we're not like individually changing the string, we could just do it in one operation.
How would you do that in one way?
Substrings.
Yes, absolutely. You can do. But substring, how does substring do its job?
You give it two size t's and it.
No, I know what it does. I know what it
Oh,
does.
cool.
But how does substring accomplish that? Substring has to have a for loop inside.
Okay. Here.
Yeah.
You just do s equals s dot sub str from. You're shifting it over n characters, so it's going to start at n, and it's going to go to s dot length -1, and it's going to get added concatenated with s dot sub
First character. You got first character, right?
0 to n.
Oh, I see. All right. So you can absolutely do it like that. Okay. What Adam just typed, you can absolutely do it like that. I deliberately didn't want to do it like that because we want to know what substring does. Yes. We want to know what substring does, and it's going to. Oh, I see. You're saying shift everything by one. Oh, I see. Okay. Okay. So it is more efficient. It is more efficient because it'll do the whole thing.
So
Yeah, unless you had
work.
the animation and so you sleep and all, it's not worth doing it one at a time, because you can move the whole thing like that. Yeah, okay. Is everybody okay, happy with using the substring function? Okay, and the other reason why I didn't use substring also is that there might be some corner cases and debugging we need to do, but we did the whole thing. Essentially what we did was take out what substring did and put it there, and also broke it down to a more atomic level. So we're actually doing a little bit more work. What Adam's got there is slightly more efficient.
If you would prefer to use the for loops, then you can start at n and then go, and then the line below you could go.
Yes.
But you
How about
can
that?
Do I
How
plus
about that?
n.
That's also possible. Okay. What Nemo said is we, instead of starting at the first character, we could just start at n, because we're going to be rotating that much. We move all of that over. That means we have, but before we do that, we have to take the first n characters from the string and store it somewhere, right? Because you need to put it on the end, right? So there's many ways in which you can do it. Obviously, more efficient ways. Let's put we put a comment saying, but where's the thing that yeah, Adam, yeah, all right. So comment out the substring part, and put a comment above that. Put a comment above that, and say slightly more efficient implementation, please play with try and come up with more. As like Nemo said, came up with another example that is also efficient, right? And so we can do all these different things. Yes or no? Is everybody happy? So this should do it, shouldn't it? Let's just shift by one. Now, if you run it now, I think. Oh wait, did we get it? Display with rotating effect. Now let's try this. Now let's try go to our main and just print a random string. It doesn't have to be this string. Print some some gobbledygook, right? So and right above above the while loop, and then we can do an exit right there, because we want to test that method. So you can say yeah, displayer dot display with rotating effect. With rotating effect and open and it just put some lots of junk in there. No, put lots of junk. You just yeah, lots of it. So now the effect should be that and then display with rotating effect and let's say oh, by the way, initial wait time. Oh, I think we didn't actually complete that. The display with rotating effect. Why does it end? Display with rotating effect. What is the exit condition there? Oh, it's num spaces and then. Oh, just let's rotate it by 10 spaces. Okay, let's just rotate by 10 spaces. All right, now let's see if it happens. Oh, and then initial 500,000, 500 times 1,000. Are those the three parameters? So first it'll no, actually make that first 1 million, okay? Because it'll start at one whole second of waiting, and then no, you're right, half a second, because it's going to slow down, not fast enough, right? It's a speed up, right? So 500, okay. Now it should start slowly, start fast, and then it should. Why is it not doing anything at all? Again, we're going to have to debug this, and it's easy. I'm actually looking forward to these debugging. When things don't work, we dig in and see why it doesn't work. Okay, so what is that? Oh, displayer. No, I don't think that'll work. Display with rotating effect. No, let's go back to our display with rotating effect. Kill this. Let's take a look at display with rotating effect, that code that we just wrote. I want to see it gets there. Does it do a cout at all in display with rotating effect? Does it do a cout in display? Go the code for display with rotating effect.
Hold on, you might not have been- so there's a little bit of no, I don't think it does a cout.
Okay, so let's go to that place, display with rotating effect. Go to the place where you have display with rotating effect. Where did you define that? Okay, you sleep interval, and then you need to do a cout here. You need to have a cout, right? Cout, a cout with a /r at the end. Cout s, cout, and then s, and then a /r at the end, right? Because you want to go back to the beginning of the same line. Now I believe that should fix it. Yeah. It's still not printing. Oh, yeah, flush. See out that flush. Okay, after the /r. I'm sorry. Okay, you need a flush too. Try now.
Definitely it's the string that I.
Okay, why is it now is slow? It should get slower and slower. All right, so let's go back to the 1.5. Turn the 1.5 into 1.1. And let's make the first one, the initial interval, when you call it, let's make that just, I don't know, 50. Not even not 50. Just make it 500. Just make it 500, not 1,000. Okay, no, 500,000. Just fine. Now I think this should be fast and then gradually slow down. No, not this. Well, what's going on? Why is it not doing the display rotating effect?
That.
Oh, you have to have a return 0 and all. Yeah, you return 0 after that. Okay, good. Now return 0. Now if you print it, I think you should get that thing. Nothing. Oh yeah. Return 0. Yeah, of course you need to do an endl and then return 0. I'm sorry, we're missing all these little things. But I think return cout endl and then I think, but still it's I thought it was it happened too fast. It happened too fast. Yeah, maybe 5,000, maybe 5,000. Or 50,000 even. Yeah, or 5,000. We'll try 5,000 and then we'll try 50,000. That was too fast too. 50,000 should be 50. Yeah.
Well, let's do 50 times 1,000.
Yeah. I think that will be better. We'll see.
There we go.
Okay.
It worked.
Is it working? It is working. It is working, isn't it?
Let's do more numbers,
Okay.
more shifts. So we
Yeah. Okay. Do that. Yay! All right. Okay. So you see the effect. So that's kind of cool. Now, what we want to do?
I have an idea.
It should slow down gradually.
It is slowing down gradually. My idea is that if the speed gets to a certain threshold, we should terminate the loop.
Yes, that's exactly what we should do. Before that, let's do one more thing. After, when you print the string, also emit a sound. Okay, so cout before the /r, also say /a, right? /a. No, inside of the there you go. Inside. In fact, turn the /r into a string with /a before it. Now /a, believe it or not, goes back ancient times, before the start of computers, maybe even, right? /a is the bell character. Now, are you hearing a bell sound, Adam, when it moves?
No.
You're not? Or maybe VS Code is not intercepting it, right?
Yeah,
if you run the same command on a terminal, you'll hear the bell sound, and you'll actually hear the wheel turning, like bip, 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 like that. Okay, that's the sound you should hear. As the wheel turns, you'll hear the sound bip, 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 bip. Right. So I think so. All right. So let's try. Can you run this on a terminal? Can you just open a terminal? Open a terminal. Go to that directory. Open a terminal and go to that directory.
On my way.
But I don't know if Zoom will pick up that sound.
I'm gonna change it over in just a second. I gotta change it.
Yeah, especially on MacBooks, they don't usually work with the sound. Even if video sharing works, sometimes the sound doesn't work.
Is it right?
So you'll have to, or /a.
No, a dot
/a.
No, it's in the different. It's in different directory, isn't it?
That was Nemo. That was definitely Nemo.
No sound.
I'm getting.
Adam, are you hearing a sound? I'm not hearing anything.
Can Nemo's laptop pick it up? I am hearing the sound.
too many people talking at the same time. Adam, are you hearing a sound or not?
Yes, I am.
You
It's-
are. You are.
It's my voice on Nemo's laptop. We were trying to get it to pick up the noise. It's definitely making a bell noise.
Okay. And Nemo is not. So Nemo's laptop is not picking up the sound either.
No. You okay? He's saying turn it up to max. Here,
Yeah,
let's-
turn up to max and maybe move Nemo's laptop closer.
Yeah, you gotta.
Hey Nemo, can you bring your laptop closer? I don't know. Okay. Anyway, by the way, you guys are going to be playing with this anyway, right? And then each one of you can write your own copy of this, and you'll be able to hear the sound. Now we can go back to our the main code that we had, in our main. Now all we need to do is when you advance, when you advance. So yeah, there you go. I think what we need to do is displayer.drawString add. So here, instead of drawString add, you're going to say displayer.rotate by 4. Is it 4? 5? Maybe rotate by 4 of 4. 5, I think. Displayer.rotate by 4.
Like, where do we do that?
Where you say displayer.rotate string, you say display with rotating effect.
Where are we saying display to?
There, right there, line 252. No, that line 252 can be changed now.
Oh,
So
you're
you say
saying, okay, I thought that's what we were supposed to do, but I wasn't sure.
Yeah. Displayer with rotating effect, and then you want to pass S, and then what else?
The number of spaces and the interval.
Right, four spaces now. 4 spaces. 4 spaces, and then we can start it off at 50,000 seconds, right? So 50,000 microseconds, and 1 sec. Okay, so it's going to do that at 4 spaces, and then it's going to advance, and then print that, and then 4 more spaces, and so on. So hopefully,
so now we don't need to. Okay, we're rotating it twice now. We don't need to. This whole.
No, that is not rotating things. That is just moving that is rotating the ring.
No,
That is rotating the
Every
ring.
time we
Okay.
call this while loop, we're rotating it with this. So what's gonna happen is it's gonna run it, and then it's gonna rotate the string that we give it 4 times.
Yes, 4 by 4 characters.
It's gonna jump that distance pretty well. No, it's not gonna jump that distance, does it? No, it should be fine. But then, oh. No, actually, you know what? This might actually just work. I'm stupid. Yeah, I'm just stupid. It's just got a weird time.
Hey, you're getting two vertical bars at the end for some
Yeah,
reason.
because it starts and ends with a vertical bar.
Yeah, and also why is it jerky?
Because we're reassigning the time every single time. We're
Oh, I
passing
see. So we need to change that. So we say outside the while loop, we can say initial time equals 50,000. Initial, yeah, there you go. Yeah. Initial wait time is 50,000. Initial interval. I think you called it interval before. I think that was better. Initial interval equals 50 times 1,000, and then here you would say initial interval. Oh, you should maybe you should just say interval, and then we need to change interval. Yeah, interval equals interval times. Yeah, I think what we do 1.1
for each.
Yeah, 1.1.
So it's 1.1 times 4 to
1.1
times
times
4.
yeah.
Which is like that's the easiest way of doing this.
1.1. However, it should be 1.1 to the 4, shouldn't
That's what I
it?
was
Because it's
saying.
already done 1.1 4 times.
I don't
now.
want to include math.
So let's say instead of 1.1, can someone calculate what is 1.1 times 4? Is it 121? 121 times 144. So 12 squared is 144. So it should be 1.4. Let's say times 1.44 times 1.44.
1.4641.
Yeah. Okay.
Put it into a calculator.
I think that should be good. Now, my only concern is that we're doing these things, but someone who watches the recording or looks at the code that is completed they will be mystified by a lot of these things. So we need to add a comment. Well, let's run it. And if it runs, we'll add a comment and clarify things so that people will. No, it's still doing this. And there's also this issue with the double bar and all. Okay,
The double bar is because the string starts and ends with a bar. And so if we're taking the start of the string and moving it to the
Oh,
end,
I
it's
see.
two bars anyways.
So maybe you can take out the last bar. You can take out the last bar. You know that OS less than. You take out line 247 altogether. It's okay if we have
here's
to.
Here's what I want to do instead, because this might look nicer. I'm gonna do
This will definitely look nicer.
plus a bar string. So that it's
Try
still
now.
a bar at the end. They always have a bar.
Compile and run it. Plus, we still have to fix that jerky thing, right? It's still very jerky. It's so every time after 4, so that 1.46 or whatever it is that you're that we put in there is, and then there's this lag. You know, it's very tempting for me to dive in and fix these little things. However, I fear that we may run out of time to do the big game. So here are options. Do we want us together to fix these simple issues and then move on? Or we can do the whole thing and come back and fix these little issues if we have time. Or you can do the little things on your own too, because these are little things. Tell me your preference and we'll do it that way. Can we just move ahead and implement the rest of the roulette game now that we've got this basic thing working? Yeah? Yes or no? Okay, great. So what time is it now? Wow, we only have 7 minutes, but we have one more class. Okay, we have one more class. And so here, and I'll explain what we're going to do, and we're going to start now, but we'll pick up this code next class and then do more with it. Okay. So what we need to do now is, Adam, you mentioned something about setting a threshold and saying once the wheel starts getting slower and slower, when it gets too slow, we stop it, and then we can say that it is too slow when the time to wait is more than 2 seconds. Okay, more than 2 seconds. That means 2 million. Okay, if the initial interval star equals 1.6. Yeah, I think that's fine. So if and don't call it, let's call it interval. No, let's not call it initial interval. We'll just call it interval, and then interval equals times 1. And then interval equals, and then we want to say if interval is greater than 2 seconds, that is 2 times 1,000 times 1,000. 2 times 1,000 times 1,000. Then you can break out of the loop. Break. Yeah, okay. I think that's, and then before the return 0, you can just print a cout. Yeah, okay, that's fine. We'll see it just to make sure that we know it's gotten out of the loop, right? Well, it's going to print the prompt, the operating system prompt, but you can say cout there if you want. Oh, that's fine.
This will work. It'll tell me that it's done.
Yeah. Now, when the wait time. Now, by the way, why is it not? Is it slowing down at all? Is it slowing down?
Yes,
it is slowing down. Okay, it should stop. It should stop at some point.
The interval might approach to really slowly.
Is interval increasing? It is increasing. Maybe it's just it's too luminous. Oh, it did wait. Okay, I think that's good. That's good, right? Because when the wheel is spinning, people are actually eagerly waiting to say, is my number going to be there or not? Okay, so all right. So here's the game in my mind is that when we spin the wheel, the number that ends up in the beginning, the first slot, is a winner. How about that? It doesn't matter, right? Eventually, when you do this, you can say the number in the beginning first is not the winner. You got to be in the middle, because you can have a pointer and whoever's in the middle is the winner. You can do all those things later on, but we'll say that the winner of the game is whoever bet on the number that is in the first slot. Yeah, is that okay? All right, good. So now what we want to do is, hey, Adam, can you run it one more time? I want to see if when it moves these things, is it moving it correctly? That that thing one more time. Can you just do A out one more time? That program, just run it one more time.
I want to make a little thing that is pointing to the center number, I think this.
Oh, you actually want to do the center? Hey, let's not do the center if you don't mind, because I fear that it may introduce a delay. Yeah, it's not insurmountable, but it'll introduce a delay in the way we do that. Oh, wait, why?
I was just gonna manually put a character like 50,
Right.
like on a string, like an empty string, 50 characters down. But I thought I copy pasted the right number of spaces, but I might not have. I'm sorry. Let's.
Yeah. Okay. All right. Good. Now, when it finished, I want to see what it looks like when it finished. So display with the fact. Let's say let's stop. Yeah. All right. When it once make it 1 million instead of 2 million, so that it ends sooner. I want to see when it stops. We should have a proper. The number should be there. The first number should be between 2 bars. Okay, when it stops.
Oh, hold on.
So make that one. Make it 1 million so that it stops sooner.
There a variable that we have.
Oh, why are you doing C in interval?
Just so we can.
Oh,
see
you want?
what-
I see. You just want to make it wait. I think it'll be all right because we're printing it and then.
That's where it stops.
Oh, that's where it stopped. Why has it got a space there? But it doesn't matter. Okay, number 3 is the winner in this case, and I bet that at that point, cur equals the 3rd node. Yes, at that point, cur should be the 3rd node, shouldn't it? Right. So when you do C
Start
in
should be-
interval, yeah,
yes,
instead
start
of
should
C
be-
in, turn that into a C out on line 258.
That was the
Hey,
wrong-
Adam, you disappear.
Wrong button.
Right, line 258. Just do C out. The winner is cur arrow number.
Start arrow number.
This is start.
Because start is.
No, I think it is.
outside of loop, so it's start's the only one that's actually outside of this. It's actually.
Oh yeah. So start arrow number. Are we using cur at all? Yes, we are. Why are we using cur?
Cur is inside
what
the
are
for
we-
loop. Start
to make the
are,
string.
like super, like this is where we are on the ring. Current is like.
Yeah, got it. In fact, what we should do is that for loop that you have there should basically don't do it now. That should be turned into a toString method of the ring class. So you say ring.toString, you should get that bam like that. And but we let's not do that now, right? You'll be doing a lot of that in 2B and all, so we'll leave that alone. Okay, so if you run it now, it should say winner is at the end of whatever that, and change it to 1 second, okay? Or one times what a million, it'll stop sooner. On line 258. No, line 253. Line 253. Make that 1 million instead of 2 million. Okay, now
250 times 1,000.
50. Yeah. Right now, I think it should also tell us what the winner is when it stops.
It should print it over this line, and then I think everything else.
No, it won't. Oh, I see. It'll print it over that line. Yes. Because we don't have an end.
Yeah,
Winner's
that's
not.
exactly
Okay,
what I
good,
thought
good.
would happen.
You can put a new. If you put a /n before the winner is, put a /n before the winner is,
Yeah,
you'll
that's
get on the next
exactly
one.
what we got to do.
Yeah. Now try it again. I think we'll get the winner.
Now we gotta wait the time.
No, 9 is just until it gets to 9, I think.
Yeah.
Yay! Okay, all right, good. All right, okay, excellent. All right, so now we're getting all this. Here's a really exciting bit about any computer science project, any programming project you get into. As we do more and more of these things, the final thing starts getting more and more shape, right? We can start visualizing what the final thing is going to look like. That is really exciting, and I enjoy this part. And I think as programmers, you could also try, maybe if it works for you. These are exciting parts. We're slowly morphing this amorphous thing we have, into this nice little structure that is enjoyable. Okay, great. Now let's do the rest of this game. What we want to do.
Oh, that's why I figured out why it's got the delay.
What was it?
This you sleep.
Oh, I see. Yeah, wow. Thank you. All right, so I had no idea that we had another you sleep in there. Excellent. And now we should say 9. Yes, perfect. Okay, all right. So good. Now all we need to do is in main, we need to first print out that roulette and say we're taking bets. Okay, and we're going to say what is your name to get the player's name, and then we're going to take their bet in terms of number of dollars. Okay, I think this is how we'll do it. Okay, this is how we'll do it. In our ring class, if you go to our ring class, no, let's go to player object. Okay.
It's
Yes,
fun to
let's
spin
go to
this,
player
this,
object.
ring. You can spin it by setting the interval up here. It's kind of funny.
Yeah.
It's fun to just compile it with a different with a different constant to make it spin, because the amount you give it determines how what number it is.
Yes, the speed, right? The speed.
Yeah.
So when so in the actual game, what you can do is select a random number for the speed that is somewhere between 1 and 1,000, and then it'll all the numbers will be different. Okay, now yeah, rand times. No, it's not rand times 1,000. It'll be rand over rand over rand max. No, rand percent 1,000. Oh, rand percent. That's what you had, right? Rand percent 1,000. I thought you had said rand.
I think this one's gonna be 20.
Yeah, okay.
I think if it's too small, it's always just gonna give you the same thing.
Yeah,
You have to tweak the numbers to balance it better, but that's a later
Well,
problem.
you can tweak it on later on, right? We have the basic thing in there. We can tweak it later on. Now all we need to do is just set up the game so that we need a player class. Okay, so let's go above main and create a class called player. Right? And create a class called player. Just above main should do. Yeah, there you go. Right, class player, and the player should have a name. A class player, and the player should have a name. String name, yeah, public string name, and then they should have money left, right? So you say size T, money left, and then the next one should be current bet, size T, current bet, right? So every player will have a name, how much money they got left. We can say that all of us playing, everybody starts with $1,000. Okay, now and then you bet a certain number of dollars, and here's a cool thing: you can say that player can place bets on multiple numbers too. That's what I think happens in a real. I've never been to Vegas, so I think that's probably what happens. You can place bets on multiple numbers. Yes or no? Yeah.
Yeah, you can.
Or can
you can put on different numbers. You can put on different colors as well, and then you can also put different amounts on different places if you're betting. That is.
Fantastic. Okay, so player SBEV. What is that? Oh yeah, change money left to balance, right? Yeah, I think balance looks better. Change the on line 201. Change money left to balance. Yeah, thank you, Walter. So that's what we'll do. Yeah, was it Walter? I couldn't tell.
Yeah, it was me.
Thanks. All right. So current bet 0. Excellent. Oh, and is it SBE? Did you say Steve or SB? I can't pronounce that.
SB. I was trying to be a little bit random about what I was naming the default.
Yeah. Okay, never mind. It's going to be replaced anyway. It's just a default parameter. Okay, now what we need to do is in our node class. Let's go all the way to the node class.
I can find it.
Node class.
You know what?
And let's say that every node. A ring is a sequence of nodes, isn't it? So let's say each node has a vector inside of that. After nodes, before nodes start next, right? The next is the last thing. Before nodes start next, you say vector of player objects inside, right? Player space. This is basically who bet on that number, right? Bets on this number. You can say bets. Yeah, all right. Bets. All right. No. And you need to take that player class and put it right at the top. Otherwise, the compiler will say, hey, what is this player thing in Node? Okay, so you need to put it right at the top. Okay, you cut it and put it right at the top.
Yeah, I was gonna add some like formatting stuff, but yeah, I guess I just have to move it now.
Yeah, absolutely, right. The code already looks pretty neat, but before Adam posts it, maybe he's going to do some formatting changes and all. And each of you should also feel free to play around with structuring these things, right? Did you put it right at the top? Okay,
I put it button.
Great, excellent. All right, now all we need to do is just go to our main, and then before we even start the game, we're going to say in our main, no, you don't need players there, right? Blank line. Enter. Right now, you want to put a comment there saying enter a loop that will ask for player names and their bets. Right? Everybody starts with $1,000. Right? Everybody starts with $1,000.
Okay, then I'm going to change the constructor for player.
Yeah. Okay, now player should when you create a player, make them 1,000. No, I think what you had before, what you had before was good. You put it there, and let's say the default bet is 1,000. Yeah. Okay. All right.
The bet or the balance?
Yeah. Any way you choose to do it is fine. All right.
I figured we don't need to give them the ability to change the balance if they all start at 1,000.
Yeah.
That's why I just said remove this and.
Okay, remove that, but rather than say 1,000, we need to have a static constant. So in the player class, you can say static const initial. Static const initial int const. Oh, const expert. Okay. Well, so when Adam says const xpr, it just means that the compiler allows you to do some more complex types than just basic integers. But we'll just say const because we're not going to use a constant expression here. We'll just say const. It'll keep it simpler. Int size t because int because it could be negative. You could have a negative balance, right? Int initial balance equals $1,000, right? Yeah, in it. Initial balance equals 1,000. Thank you, Adam. Right? And put a blank line after that because it's static const, and then we have these other things. Okay, so initial balance, current bet 0. All right, so now we get to place the bets in there. Okay, now we can go to our main. By the way, this program has gotten to pretty big. I want to make sure, but this is the end of the quarter, so hopefully everybody's up to speed. But I want to make sure that nobody is feeling overwhelmed by the size of the code or things we're doing today. Because if people are feeling overwhelmed, there's no point in doing this at all. Okay, because this is an idea, you can run it in your head. I want to make sure, because Adam seems to have experience and I'm just, going with the flow of the coder with completely disregarding other people who may not be on board. So I want feedback here. Please tell me, raise your hand if any of you are feeling left out. Okay, if any of you are feeling left out, I don't care if we don't finish this project. Okay, we just want to make sure that every concept is nailed down. Okay, please raise your hand if you're feeling left out and you can't follow the code. Okay, no, can we all keep moving forward? Yes or no?
Implementing a more realistic.
Well, I don't know, Adam and Nemo are not even listening. Can we guys keep moving? Okay, can we keep coding, or is this too much for you guys?
I think we're fine, but we've hit the time limit.
Okay, great, excellent. All right, so all right, enter loop. So now we can say, for while we need 3 variables, right? We need a username, because we want to create these player objects, right? So we want to say username, and then int user bet. Okay, now we need to get into a loop while you can actually just do while, right? While get line username Yeah, I think that should do. Basically, it'll if the user types in a username, that is going to succeed. Okay. If the user says just enter, that's the end. So here you can say, and then you need to do print a prompt. Oh, we need to print the. Oh, yeah. Okay. All right. So we need to change that while loop. We need to make it cleaner. We need to make the while loop cleaner. So what we need to do is we need to ask, right? So let's make that a do while loop. Okay. Do. We're doing this other loop here. Okay. Do. Just say do. Yeah. Space. And then inside of the loop, you say print the prompt. Inside of the loop, you say print see out what is your name. Enter your name or enter your name. See out, enter your name, and then accept the username. Name. Enter. Yeah. And then accept the username on the next line. So get line. No, you have the string out there declared already. So and then on the next line, you're going to say if username is blank, if username equals blank string, you can just exit, right? No, break out of the loop, right? Break. Now, after the prompt, enter your name, you can say hit enter. Hit enter if no more players or something like that. We got to say hit enter if no more players, right? In before the colon or something, you say within parentheses, you can say hit enter if no more players. Okay, all right, good. All right, now what we want to do, enter your bet. You have $1,000, right? Or enter your bet, you have this many dollars. So you need to get, you don't have, this is the first thing, right? Enter your bet. You have. Eventually you can change this so that you can put the whole thing in a loop so that the balance is also in there. People can keep playing as many times until they run out of balance. Okay. So you don't have to say you have and all. Okay. Oh yeah, all right. You can say you have. Leave it out for now. Right? You enter your bet, username, yeah. And then colon, and then accept the number, colon, and then yeah, there you go. And then you want to say see into user bed. Oh yeah, I can do, yeah, see into user bed. We'll keep things simple for now. Now what we want to do is construct a player object and put it. Oh no, what number are you betting on? You gotta ask what number you're betting on, 1 to 20, right? Enter a number from 1 to 20. So and then one more prompt. We say what number are you betting on? Enter your.
I bet 10.
Hey, we're not playing the game yet, right? A question mark, not comma, question mark, after on. Oh, I see. You got that there. No, turn the last colon at the last colon on line 265 into a question mark. Now take that question and get the put that before enter your bet, right? And we can change enter your bet to how much do you want to bet. I think that sounds better. Yeah, there you go. Okay. And you don't have to second time you don't have to say username. Okay, then that will get too much for the user. Is a first time username, and second for the second prompt, don't put the prompt, don't put the name of the user, right? How much do you want to bet is sufficient? No, on the second one. How much do you want to bet? Question mark. Okay, good. All right. So you're using user bet, cn num. Now after that you can construct a after that you can construct a player object, and you say player space player, and then open parentheses. You say username comma, and what was the other one? The balance is not given. The bet, the amount.
There isn't another parameter. We have to manually set that inside player. I mean, we could change it so.
Oh, you don't have a.
No, there's only one parameter.
Let's put the thing there. Okay. Where's the player class? The player class.
Good question.
Yeah.
I can use Control F to help me, please. Okay.
Yeah, player class. A current bet. You have a current bet right there. Oh, I see. Int bet equals 0.
This
No,
needs-
int bet. You can't have a default parameter there. Int current bet, and then you say int bet. Yeah, okay. Right. And then current bet should be bet, not 0. Okay, good. So no default. Let's say no. Let's not have a default. Mandatory parameter. All right, int bet. All right. So I see. The first one is let's not no defaults anywhere. Okay. And not string
the
n.
name to be passed in
No,
anyways.
not
It
string
doesn't
n.
matter if
No, you
there's-
have string n. Don't call it string n. N should be a number, so it should be string s.
It doesn't matter if we, it only gets called if we have a name anyway, so we don't have to worry about there not being a name.
Yeah. No, it's just the name of the parameter. That's fine. Username, comma, num, and also call it bet instead of num, or user bet instead of num. I see user bet. What is num then?
I think num is what number you're betting on.
Oh, yeah. All right.
Didn't know
Now
what to call
on the
it.
next
It's
line,
probably
after that, you want to say node star node. Gee. Okay. Now you want to say ring dot.
No, it
set
should be
player
start,
bet. No. Let's do a method for ring.
no, because
Okay.
this is,
So
okay,
just
so I moved this below the start declaration. Isn't the goal to be, so this is inside our big while loop, and this happens before every time we spin? And wait,
So here's what I'm thinking. So I'm thinking that the ring has a number of nodes in it. Yes.
yes,
So what we can do is every node also has a player object inside of it. In fact, what we should do is every node has a vector of players inside of it. What we should do is essentially have a method for the ring class, that is add bet, right? Ring.add bet, and then player, comma, and then num. Okay. Now in our ring class, we need to have an add bet method. Add bet, and you can make it void for now, right? And then a string player, and then size num, right? A string size int num. Is it not size t num? Because it's the number, right? It's the index, right? Now this method is very easy to define. So in our we can just define that method, right? Let's define the method, and we'll have time for that. No, not there. We'll just define it out of line. Thanks. Okay. So, right. Is it together with the other player methods? No, other ring methods. The one above that is also a ring method, is it?
it's the deconstructor.
Okay. So here, what we need to do is essentially step through the ring, starting from the beginning. And when you find num, you add the player to the vector inside of that node. That's all. Yeah. So for size t, I equals for cur node star cur equals ring dot first, and then cur not equals to not that may end up in an infinite loop. If you get given a number, if you get given a number that is not in the ring,
Oh, yeah, that's true.
You want to go
Yeah,
size. No, that is fine. So for I see. So you want to go
Or
from
cur
0
next
to the ring
equals cur.
size.
Next.
No, I think that complicates things too much.
Yeah, it probably does. What were you saying?
So just do from 0 to ring size, right? Just do 0 to your loop itself should be 0 to ring size. There you go. Yeah, exactly. For 0 to ring size. For size t, I equals 0. I equals 0. I less than ring size. Yeah, ring size. No, ring. Plus plus. Ring. I see. It's a method. Okay. Right now, what we want to do in here is, and you got cur equals cur next. Okay. So you can, and now I can say if cur arrow, is it length?
Yeah, it's length.
Okay. If cur arrow num equals num, then cur arrow players dot pushback. Cur arrow players. Is it players? I don't know what we called it. What is it inside the node? We call
It's bets.
oh bets dot pushback player. All right, that's all. All right. Now that should do it, shouldn't it?
That should do it.
Right.
That's
So that should
fantastic.
basically take the player, add it. So we have this ring, and inside this ring we have all these nodes, and each node has a number, and then it has all the players that bet on the number, and each player tells you also how much they bet. Yes. Now we have all the information we need for the yes or no. Yeah. Okay. Great. Now, oh, you started the game already. Okay. All right. Oh, you can't bet 0. I mean, you got to be more courageous here. Okay. Well, 10 for
Oh,
Robert.
that's
Okay.
100.
Robert said 10. Robert, you said 10, right?
Hold on. Robert,
What's going
Again.
on?
Robert,
10.
Yeah, again.
what? How much do you want to bet?
Oh,
You got $1,000.
yeah. Oh,
All in?
1,000.
All in. Let's go.
He's going all in. All right. Okay.
Hey, that's a bonus.
Now, the thing is, when it may say that it may end up in a place where the vector is empty, and then we want to make sure. Oh, the winner is 20. All right. Good.
I hope
All
you.
right.
I
So,
hope you guys like the number
what we want to
20
do
for all the kids.
is after you find the winner, what we have to do. Hey, are you guys paying attention? That's all, right? It's very simple. We're almost at the end. After we find the winner, we got to look at the bets vector. If the bets vector is empty, that means nobody bet on the number. No winners. Yes? After we find the winner, we look at the bets, and if bets is empty, nobody bet on the number. However, if there are winners on that number, all we're going to do is take the current bet, multiply it by the odds. Well, we got 20 numbers here, so it's 1 in 20. So the house, so you got a 1 in 20 chance of winning. That means that what is 1 over 20? Is 0.05? 0.05? Yeah, and so the odds should be such that if they win, it's whatever you bet times 20, right? Times 19. If you win, you get what you win times. If you win, you get 19 times what you bet. Okay, I think that is good because the house will always be up. Because a casino, you can't run a casino if you do perfect odds, right? Otherwise, your casino will shut down. Every casino has to have a gambling. All their gambling machines should always have the odds slightly stacked in favor of the casino. Otherwise, the casino will go bust, right? And so the people go to the casinos hoping that they have better odds than the casino, but really they're only hoping that someone else will be unlucky and you win, because the casino will never lose. The gambling house never loses. Okay, they always make money. If you make money, it's because someone else lost. It's like the stock market. Yes. So you got to make sure that you always you're running game. You got to win. So you only pay out 19 times, not 20 times. Right? The odds of winning are 1 in 20. But you pay out 19 times their bet. Okay, so you can say length minus 1, right? You can have a big wheel, still it'll be length minus 1, or length times 0.9 or something like that, right? And then ring size, p balance, not balance. You can't get a balance. Oh, I see, balance equals. Oh, I'm sorry. Well, so Adam is doing a lot of stuff here that I'm not. He's probably gone ahead and done some stuff. Oh, you're adjusting the balance here. But you want to say how much they won too, right? So so after they won, hey, Adam, don't do that other for loop, okay? Because I think that let's leave that other for loop other kind of structure. I don't want to confuse students any more than we have to. So size t I equals. No, wait a sec. We don't need a loop there. Why do we need a loop there?
We got to go through all the people who won at this.
No, there's only one winner. There's only one winner.
There could be more than one.
No. Lots of people bet, but only one winner.
Vector of number. It's a vector of players at that node, So we
Hey,
have
I'm
a
sorry,
node
sorry,
that
sorry,
won,
sorry. Yes,
we
yes,
have
yes,
to
yes,
go through
yes,
all the
yes,
people who won.
yes, yes. Okay, all right. One winning number, but many players. Okay, so bet start size. Okay, bet start size. Thank you. I'm sorry. Okay, so what we want to do is balance plus
There's a
equals.
reason why I wanted to do it that way.
Yeah. Absolutely, you're right. You're right. Okay, start dot. What is start dot bets? Why is it start dot bets? Why is start?
Start is our winning node.
Oh, start. It's not current. It's not start.
Yeah, start is our pointer that like kept track of where we started in the ring when we.
Oh, I see. Okay, all right. I thought it was.
Bets is the number of
Bets
players
of
who
I,
bet on that node, and then the balance is the balance of the player who we're currently looking at in the for loop.
Right. Can we do that in 2 lines, Adam, if you don't mind? Go. So on the
Yeah, I
previous
think it
line,
makes
let's just say
sense.
how much they won. Let's just find out how much they won on the previous
Yeah.
line. So say size T winnings equals. No, leave that line alone. No, we want that line anyway, right? So it's our. You go to the previous line and say size T winnings equals. Winnings equals bet times ring size -1, and ring size -1 should be in parentheses, right? Because it is yeah, there you go, ring size -1, and then you can say balance plus equals winnings. Oh, and also when you accept the bet, you have to subtract whatever they bet from their balance. You forgot to do that.
Yeah, hold on.
Yeah, that's one step. One step. If you go up to the place where you accept the bets in that while loop where you're interacting with the user, up further up. Where are you getting the usernames and the bets and everything? There you go. How much do you want to bet? You want to say, oh, I see. We don't have a method to do that. Oh, we don't have a method to adjust the balance. No, wait, no. Ring.add bet. So yeah, ring.add bet should do it. So let's go to the add bet method. So when you set the bet, you should also subtract it from the balance. Set the bet and subtract it from the balance. So
it's
where's add bet? Where's the add bet method?
Add bet only adds the player to the bet. To the bets thing. I'm sorry. I just really need to get this done. This is just my brain. I can't move on to anything else until I finish with.
No, where is the player? Where are we making the player object that we pass to add bet? Where are we making the player object?
The player object that we pass to add bet right here.
Right there. Okay, right there. Oh, I see. Player. Oh, because we don't have these.
I've got an idea. I've got an idea. This is going to be a really good idea.
If we have places to go, could we head out now, by the way, because we're overclassed?
Oh my gosh. Oh, all right. Okay. All right. So I think we're in a good place now. We can. So how? Let's take a vote. How many of you think that we can wrap this up in the next? Not today, right? On Thursday, if you are confident that we should be able to wrap it up in 15 minutes. We're very close to the end, right? Very close to the end. We just need to wrap it up and play. Do you think? I think so, right? I think we can just wrap it up really quickly in 15 minutes as soon as Thursday's class starts. Do you think that is a reasonable statement to make? Yes or no? Yeah, because we're so close, right? And and the other thing I need to find out is, are you all jazzed up enough to look forward to Thursday's class so we can wrap it up and actually play a game, right? Because if you think, oh, well, we've done it, it's boring, there's no point, right? Is it fun enough for you to come back on Thursday and wrap it up and see what happens, and we can actually play some games? Yes or no? Nobody's going to skip on Thursday? All right, please come, right? Tell all your classmates to come on Thursday too. We'll actually have a real game, right? We'll play this. Hey, Adam, before you post this code, if you can just clean it up, reduce the number of lines, get rid of unnecessary comments that we stuck in as part of, instruction and all. Is it possible? Can I impose on you to do that?
I could go through. I mean, a lot of this stuff is actually kind of useful comments, but.
Yeah, okay. Well, leave out things that you think are useful, but if you can just clean it up, also refactor a bit so you can move stuff around and all, and post it, and that'd be really cool. And I think that we should be able to, yeah, Adam, and I'll also bet. I will bet.
I think
I'll
you
bet
can only take one bet.
$100.
I think it's bugged. How much do I want to bet? Let's bet 1,000. I want to be rich today. I know it's 20, by the way. It's never 19. It's already 20.
Oh
Ooh.
wow! How did you win? How did you win so much?
He knew.
You actually won?
I
You
know
won?
it's only
Did you actually
20.
win?
It can never give anything besides 20. The number that we give it for its initial interval is like the numbers that the math, the way it works out, this constant that we're giving it, that's like a random number, it's only ever going to
Oh,
come out.
do SRAND. Oh yeah, because you have to do an SRAND in main. Did you do an SRAND in main?
No, no, it doesn't matter
Yeah.
what this random number is. This is
Oh,
this
it
is
doesn't?
always 20. It's always 20.
Okay, so that's a bug. Okay, that's definitely a bug, isn't it?
No, I mean, like, it's within this range, the rand is always, it's like, it's gonna be 20. Like, there's, with the current numbers, you have to tweak it. Like I said, you have to balance it. If you don't, it's 20. That I know that it's 20. I've seen it enough times that I know that this thing gives 20.
Even if you do an SRAND in main, even if you do an
Okay,
do an SRAND in main. No, not there. No, main. No. Go to main. Go to main.
I'm in
Is
main.
this main?
This is
Yeah.
main.
Okay. SRAND time 0. SRAND time time t no time 0L 0 no time 0L time 0L. No, but within parentheses 0 and make it uppercase L so it doesn't look like a 1. 0L, right? And then put unsigned in front of time because unsigned, and then put a blank line after that statement so that it's separated out. Okay, now I think you should get different numbers than 20. Oh, unsigned should be in parentheses. No, unsigned should be in parentheses by itself. And then right. So I think you should get different numbers. Yeah, okay. I'll bet $500. All right. Okay, 20. Right. I'm pretty sure we'll get different numbers this time because we're sleeping for a different amount of time, right?
Wait, actually though,
told you.
There you go.
that's crazy that it just gives 20 like a bajillion times. And then
No, it has to. It's predictable. It will always give you the same number because we're not seeding RAND. If we seed RAND, you get different times each time. Otherwise, you get the same thing over and over again. Yes?
That'll do it.
Yeah. In fact, you can say, when you say no winners, you can also say the winning number was this, right? You can also say no winners, the winning number was, actually, we know what the winning number is 4 because the first number is 4, right? So, so if you run it again, it'll stop in a different place, not 4.
Yeah.
Do we want to
In
add?
fact, more people can bet. More people can bet too. And then we need to say, and put
I'm
a
sorry
two-line
for
null at the
and
end.
everything,
So
but this do while loop doesn't work. It just runs it once.
Hmm?
This do
Oh,
while
oh yeah. We know we never got around to doing this. And you're saying it only does it once?
it only does it once.
You mean it doesn't get multiple players?
It doesn't get multiple players. It just doesn't. Here, look, we could do it the right way.
Yeah. Obviously, this needs to be refactored. Then wait a sec. Do while get line username, and then username is not blank. Why is it breaking out of the loop? See in user bed. Oh yes, of course. Get line. Because we're using CN, that's why. Oh, bummer. Okay, it's because we're using CN. So for the last two should also be get line and then iString stream. So here's what's going on, right? Because we're using CN to read in a number, it's just reading in the number and leaving the /n behind in the buffer, right? And so when it goes to the get line, it reads the /n only, and it gets a blank line. It gets a blank line and it breaks out of the loop. Does that make sense? Why it terminates quickly? I don't know. Nobody's nodding their heads.
I think so.
Because if you change the
line needs to be used too.
So I'll show you how to do this, right? Let's and people who want to go can leave, but this is the only change I'm going to make now. So instead of CN, you just say get line user input, get line user in and we need another variable called user input, right? So CN comma user input. No, CN comma user input. CN comma user input.
Okay.
Right on the next semicolon on the next line, you're going to say no, yeah, I string stream is space is, within parentheses you say user input, semicolon, next line you're going to say is double greater than is right shift into user bed, or whatever that thing was, whatever you were trying to read in before. No, I think it was num. Yeah, okay, now do the same thing for the other one too. Yeah, and black line after that. Okay, now this should be user bet this time. Okay, now it'll work. It'll take multiple users.
Well,
User input, comma, yeah, after username. No, after username you can say comma user input. These are all strings on the same.
but we could also
can
do, well, I'm gonna do a bunch of refactoring then, now that that's a possibility.
Yeah, you got to do a bunch of refactoring later, so I'll leave that to you, right? So the unfun part is always done by the students. This is a professor usually does a fun part. Okay.
Not doing but
What is it? Oh, you need to stream right at the top, hash include.
oh, I know. No, we have string. The issue is we're redefining
you do.
this.
Oh yeah. You don't need to do that. Yeah. No, you can basically just.
Too lazy.
Yeah. That's fine. Adam, yeah, I'll go $500 now on 8 $500 on 8. All right, Robert, $10 on something.
It's the
Walter,
number.
you want to bet?
Yeah,
What
let's
number,
put
Robert?
800 on 15.
Okay, Walter's putting $100 on 15.
Okay, in Robert's name.
Oh, right. You know, I thought Walter was putting $100 on.
I already had Robert put in by the time Walter spoke up.
He's the middleman, I
Okay.
guess.
Maybe he can place his own bet, right? Yeah, Walter plays your own bet.
Gonna go with my old pal 20. What are you saying, Robert? You're gonna do it in Walter's name now.
Okay, 1.
Okay, how much?
And I'll bet 1,000 for him.
Oh well, hey Walter, he's playing with your money, man.
You gotta speak up, man.
Okay, all right.
Here we go. Who won?
Nobody.
4.
No winners. Okay, no winners. And I thought someone bet on 4. Nobody bet on 4.
Nobody bet on 4. No.
Oh wow. Okay. All right. Cool. All right. It's fun. You can see where this game is going, right? So you can put that whole thing in a loop, and then you can add some more bells and whistles. And actually, it's pretty cool to play, right? You can play this at a dinner table. You can play this on a dinner table. And
the only thing that's missing would be the color portion of it, and all that is I believe it's odd numbers are red and even numbers are black, and then it's like a 50-50 chance almost, and then it's like
yeah. Someone mentioned that before.
It would only be a few lines of code. It wouldn't be that hard to add.
Right. Actual roulette betting.
Well, anyway, I don't want to take up your time for that, but bells and whistles like that, you guys should just feel free to add and share multiple versions of this game. You can share, this Adam's version of the game has color in it, or Walter's version has color, and Adam's version does something else. And feel free to knock yourselves out. It's just be let your creative juices flow and have a lot of fun. I'm very glad we actually managed to play a game today at the end of today's class. Well, past the end of today's class, but we'll play more. Okay, we'll do more cool things to this game. We'll pick up this code, but before Thursday, please, everybody, look at this code. Okay, review the code that Adam is going to share. After cleaning up, he'll share it on Reddit. And please review the code and try to understand everything. If you don't understand anything in this code, ask. And Adam is going to reduce the number of lines. It's not going to be like 300 lines and all. Okay, so it'll be a reasonably small program. Look at it and say, hey, can someone explain lines 22 to 40, something like that. Okay, people should feel free to ask those questions, and let's all get on the same page on Thursday, and we can play this game again.
Just take all these comments and just convert them into like text on the post. So like
yeah, absolutely.
That way,
up to you. Yeah.
Or where
exercise your own judgment. Yeah,
it'll be clear.
Whatever you feel is going to be good for presenting the code to other classmates, just feel free to do it, and I can trust. I totally trust your judgment on this. So go for it. I think it was fun, right? You know, partway through the class, I started thinking, well, you know what, maybe today we won't be able to play this game. We're gonna do this next class, but we actually managed to complete it and play it today. So thank you all so much for this opportunity and experience for me. Okay, so I had a great time, and I look forward to seeing you all on Thursday again, and we'll take it to the next level. And you know, otherwise we'll just have fun. Okay, we'll do whatever we want. And week 12, I'm happy to give you a review class on any topic. Okay, any topic that we've covered so far, just do a review class. You can say, hey, Prof, I don't understand passing by reference. Yeah, okay, no worries. We'll talk. Week 12 is open. We can talk about anything we want. Yeah. All good now? Everybody okay? All right. Thank you all. Thank you all. I'm very happy, and I will look forward to seeing your smiling faces once again on Thursday. All right. Okay. Bye.
Professor, can I talk to you about something?
Yeah, sure, Susilo, go ahead.
Okay, so you told me like in the beginning of the quarter that I should go to like a more comfortable place first, then you open up the syllabus quiz and then the data types.
Yeah. Are you ready?
Yeah.
Okay. Yeah. I'll remember to set it up today. Just to make sure, if you're able to, just send me an email so that if I forget, my email will remind me. But I'll do it today. All right. And when do you want to take it? Tomorrow?
When do you think is a good? Okay, tomorrow.
I think I'll open it up the whole day tomorrow. You can take it anytime you want.
Okay, that sounds good.
Yeah.
Okay.
Very good. You're doing really good, Susilo. I'm very happy that you're in class. Okay. So awesome. Excellent.
Okay. Thank you.
See you guys later. See you later.
Yeah.
Bye.
See you.